fast. So then you don't have to think about it. So anyways, I will always keep asking this question about why are we not allowed to feel even a tiny bit of motion. And of course, they'll give me the other gotcha, which is like, oh, we move at such a steady pace. That's why we don't feel it, because you can only feel motion when the velocity changes. But we already know that the velocity does change here and there. And of course, their answer is, oh, well, it changes so gradually that you can't really feel it. So they always have all these dumb answers that are completely contradictory, and none of it makes sense. So this is one thing I will always keep on asking.
Nice. Shout out to you. Liliana is a legend. All right, who else we got? I don't know. Run Boston, was your hand up?
No, I just see LaQuay's next. It's the only other hand I see.
Lukey. Right? It's Lukey.
Yeah.
G'day, mates.
What's up,
How you
brother?
going? Yeah, I just wanted to say thanks for everybody. And Mordwand, I'd like to commend you, mate. I've noticed your journey on here coming into these spaces. And yeah, I've got a lot of respect for you. Because, yeah, there is a lot of ego and pride. Well, pride protecting the ego. When it comes to something as big as this, being taught something your whole life and then to have that position challenged, especially if you've got quite some knowledge on the subject, and even more so if you've gone to uni and paid, hundreds of thousands of dollars on such a degree and or studies. But yeah, I think it's important to come into these things to be completely humble and to look honestly, and that's something that gets talked about a lot, is intellectual honesty, but also to know, we must be fearless and thorough. That's really important because our pride and our ego will hold us back, and it inevitably will hold back society, and we must be the teachers of our children. Like I said, we must be fearless and thorough. There is no stupid question. And to set that example is the way that we change the education system. I know that in America, you guys are talking about, Trump's come out saying that he's going to put it back on the states with the education system, but it starts with us, so there is no wrong question. And here in Australia, definitely, I've worked in youth services and community services for close to 20 years. And to touch on the iPhone, that's where these kids get their ego a lot of the time, is that they know everything because the answers are right there. But, I guess like in that journey of saying that or showing these children, our children, that that is not where you get the answers. It's for you to be fearless and thorough and be impartial and objective and to gather as many facts as possible. And if something disturbs you, it's probably, something within yourself on a personal, spiritual level that is holding you back from finding the truth. And I'll leave it there because I'm just about to jump into a school, actually, and work with a young person who is suffering from such an ill, like to a more extreme level. But anyway, thanks a lot, guys. Really appreciate everybody. And I commend Mordwand, and you are setting an example for other Globers. So cheers.
I very much appreciate that. Thank you very much, sir.
Thank you, brother. Very nice words there. Caller Ty, I see that you are not muted. I just heard your mic, but we'll just let you go ahead. What's going on?
Oh, hi, Witsit. This is the first time I ever called into a space. I don't even know if you can hear me.
I can hear you.
Really? Good. So yeah, I went to I took a trip and I was taking pictures of the mountains here in Montana. I had you and like Owen Benjamin and like 6 other guys on a thread, and I was trying to prove that I could see like the crazy mountains from like 120 miles away. And these guys like kind of barraged on me, and you and Owen didn't respond, which is fine. I don't care. But these guys like barraged on me and started debunking everything I had, and kind of proved to me that I wasn't seeing those mountains. I was seeing a different range of mountains, and it kind of culminated in me taking a photo from Belgrade, Montana, where this app called the Peak Tracker, like, noted that I was seeing 6 Mile Mountain and some other mountain, and these guys took screenshots, my screenshots, and analyzed them in like the Peak Tracker app, and they kind of debugged me on flat Earth as to like the elevation angle from where I was standing, and the 6 Mile Mountain, which is closer and shorter, being higher than the Mount Edith that was further and taller, and saying, kind of debunking my flat Earth. And I was like, I've been a flat earther from the beginning. Like, Math Powerland is the very first video I saw, and I was there in the space listening intently for years. And then Jaron and those guys came around, and the flat Earth asshole and all that. And I have been here since like almost day one. And this is the first time I've ever like seen a debunking, and it was so simple. Uh, because for angle of elevation and stuff like that. And these tweets are on these X's or whatever you want to call them are on my X account that I finally got back on after like being banned for 7 years, and for making fun of David Hogg, actually, just like Owen Benjamin. And I would love you to look at this and see, like, how to, you know I'm open to anything. I don't feel like we're moving, but they kind of debunked me as a flat earther with my own pictures. I'm sorry to go so long.
No, you're good. Yeah, like I don't remember seeing it, so I wasn't like ignoring you. I will check it out. I'll click on your profile in a second, check it out. But obviously, in a very simple, simple way here, is if say you have a two buildings, and the building in the back is taller, right? But if it's further away, because it's shrinking in angular size in the distance, and you're closer to the building that's closest to you, even though it's actually shorter than the building further away, it's going to look like the building closest to you is taller. So, like, what always happens is they never account for angular size change with distance. They assume perfect Euclidean geometry, which has been disproven for perspective, and then and you get into like, well, cherry picking the observations, right? When you don't have the most optimal conditions, you can't see as far. That's perfectly when the Earth's supposedly a globe, although the horizon isn't actual, but I swear it is. There's an actual one there, or whatever. So, yeah, as soon as I see someone actually explain, for me to even take them seriously, they need to actually account for angular size change with distance, and they don't. So, like, I can block out a mountain with 20,000 feet in elevation with my thumb, right? My thumb can block out an entire mountain just
That
because the thumb is closer to my face, right? So if it looks like the, and I think I'm understanding what you said, maybe I'm not, but if it looks like the mountain that's further away is lower, it's not because it's going down around a curve, it's because it's actually optically shrinking and compressing into the distance.
Oh, so you're saying that the elevation angle line is incorrect because it's not accounting for the perspective.
Well, I don't know exactly what the image is or what they did, right? I'll have to look at it. But I do know that they're not counting for perspective. They're assuming Euclidean perspective, and they're not accounting for angular size change with distance, which is wild. It's wild, right? If your position requires you neglecting something as basic as the fact that we know that things shrink optically due to perspective, then that's a terrible position. And that's what they do. That's what they do whenever they make these claims about like theodolite observations with other stations, and they never account for angular size change with distance. So that's pretty basic thing, you know.
Okay, and one of the guys I was going back and forth with for about a week. It was pretty fun. I mean, I took dozens of pictures, and I actually got a video of the sunset behind a mountain range. from the highway, and it was a great couple days because it was so clear out here. And one of the guys was like, said he was military, lives in Germany, maybe retired, and he sent me that he was like, he's a professional, you know, like he was asking me like what my credentials were, which I don't have any on like anything but sports. But he sent me the have you ever heard of this, the World Geodetic System dash 1984 WGS, which means World Geodetic System dash 84 manual, and it's like a 138-page document. I've been going through it. I'm on like page 10 or so, but it's all about these guys like perfecting the ellipsoid of Earth, and you know, it's a government document that he told me to check it out, and I've been reading it. So, you know, like I'm dedicated to the subject, and I've been here for a long time, and I just so appreciate a smart and young person like you who came in and kind of went to leadership role in the argument, and I imagine when I shut up that you'll probably say, yeah, you're familiar with the document.
Yeah, I appreciate the kind words, and yeah, when you really look into how they made the WGS 84 model, it's hilarious. They actually have to arbitrarily deviate the vertical, meaning like when you actually go make measurements, you establish a local vertical, a plumb line, and they say, oh well, yeah, you have to do it as if it's truly vertical and perpendicular to the plane Earth. You have to treat it that way, but really, if you zoomed all the way out, it would be tilted relative to the center of mass. So what they do is they start arbitrarily deviating it. And if you actually look at the primary geodesy documents, the just looking at the image, the illustration of how they do this is hilarious. They take the plumb line, and to make the math work, they start making it wiggle every which way, and they arbitrarily deviate it as they need, and it doesn't match. They can't get it to match. So then they start fudging with gravity, the gravity value and gravitational anomalies to try to make it work, right? And then they've taken this assumed size, thus made the assumed correction to deviate the vertical, which is obviously not actually observed, it's just assumed. And then they've had to fluctuate gravity to make it match. And then they've extended this up to a celestial coordinate system. Then you start to get your longitude and latitude worked into from the celestial mapping worked into the WGS 84. So basically, it's taking all the plane measurements and then assuming the sphere, doctoring and cherry picking with like Texas sharpshooter fallacies until you get what you need, weighting the means, doctoring gravity, deviating the vertical, and then building the overall geodetic model by imposing the presupposed curvature rate. I know it was a lot, but that's where the WGS 84 actually comes from.
No, I definitely noticed. I was reading just in the first, 10 or 12 pages that they were claiming that gravity was like more forceful in other areas than other areas, and I'm just like that is such a claim. Gravity's supposed to be a constant, but it's going to be a little bit different in this area over here, and I'm like thinking how these guys are trying to measure the ellipsoid or the oblateness of the earth, that they're just looking for a wiggle room to flatten it a little bit when they want to, and to globe it up when they want to, and just be deceptive about which one they're doing at the time, and just use it how they want to use it. But
Yeah, it
I like
sounds like you actually weren't debunked, and you just need to look into it a little further and figure out where the WGS 84 stuff comes from, and make a more coherent reply to these guys and show them that it's just perspective, man. You haven't been debunked, bro.
And what's so funny is their whole main talking point is that that's because gravity is constant, all objects fall at the same rate, that their model has to be true or whatever. And
no to
but they
tell
do
us.
they turn around and they constantly fluctuated because the observations and the measurements never actually match their model, and so they're given like this free reign to just arbitrarily doctor the numbers as they needed, and they do that with literally everything. They do that all the way up to the cosmological scale.
that was the first thing I noticed. Like, I started reading the document. I'm like, this document, like, I can't pull up the tweet as fast. I'll let you go. But this document is like just your plausible deniability document. And then on the back end, after they make the document, they're like, well, communications have been more efficient in around the globe because we measured the oblateness so perfectly this time, and we took into account the variable gravity of the going through different densities of the Earth. And I'm like, I've been all over the world standing on a scale to weigh in as an athlete, and like I could travel from here to Australia, and I weigh the same thing. It's not like it's not like the spin or the terrain. You can suddenly claim that to be have gravitational deviations when for like 100 years you're saying gravity is a constant.
Hey, are any of these guys PhDs, by the way, that you're talking to?
They I don't.
I would be. Oh, sorry. I think that was.
No, they're not. I'm saying I just went and I'm looking at his page. They're absolutely not, bro. They're like anonymous people with French fry profile pictures and stuff like that, just saying it's a definitive fact. Surveying, use it. There is no debate. So anyway, I just replied to one of them. But thank you for jumping in, man. I'm gonna look at some of that stuff and yeah, I mean it's pretty simple, bro. They think that if they just presuppose their belief system that they can make up anything required to hold it up as true, and then that somehow makes it true. So but if Alan and him are really gonna want to talk, I guess we need to try to run through the hands. But thanks for jumping off for jumping up and talking, brother.
Thanks, Wizard. Thanks for doing the stream. Take care.
Yeah,
Hey,
much
don't
love,
feel
bro.
rushed though to get to us because we're about to get into like a really long, tenuous thing. So, let people
Yeah, no, it's all good.
get their thoughts off. It's
It's
all
all
good.
good. Who do we got here? New perspective. You've been in for a minute. What's up, bro?
What's up, bro? Dude, you had some great rants. I've just been enjoying listening to it. Perfect timing on Let Me Talk because I'm about to get into a 30-foot hot tub. This thing's incredible. It's an amazing place. I'm happy to be staying tonight. And Mordwan and Alan are going to definitely be a very intense, very complicated discussion to listen to. So everybody tune in and maybe replay that later. Piezo wants to talk, but I was just going to say great job so far. And yeah, I had some thoughts earlier that I'll just save for later. And I'm looking forward to this thing with Mordwan and Alan.
Cool, man. Thank you, man. Much love to you, of course. The homie. That's a big hot tub. All right. Pieza, what's up, bro?
What's up, man? Nice to see you guys up here, brother. I just wanted to touch on one thing real quick before y'all go at it. Talking about in the context of geocentrism and kinematics and dynamics, most people will readily give the kinematics equivalents. But the dynamic equivalents, a lot of people like to fight about that. And even though there's a tentative acceptation of it by people who are informed within the sphere of this discussion, amongst academics. But the thing is they don't like to accept it because of the questionable causation. I was going to say, basically, in the current paradigm, the heliocentric paradigm, relativistically speaking, they don't have a cause that works, right? They presume a cause. They started presuming the cause was, gravity was caused by mass, even though originally, as you said in one of your recent episodes, it's not that it's caused by mass. It was originally postulated to be a property of mass, a property, not a cause, right? The cause was unknown. It was just known that it was a property, right? Gravitas, mass had it, had weight. And then relativistic paradigm, they presumed it to be, mass bends space or space time. And then, of course, that didn't work because they ended up coming up with dark matter and dark energy to explain the 96% discrepancy in that model. So that they still don't have a cause. But the reason that they don't want to acknowledge the dynamic equivalence in geocentrism is because they'd have to say, okay, well, let's say that it is equivalent. In order for it to be equivalent, you'd have to have the entire universe orbiting or circling or turning around Earth. So that's fine if you want to believe that, but what are you going to say is driving that? Right? And that's the barrier to most people accepting it, because they can see that, okay, it would be equivalent, but what's powering this whole machine, right? What's running it all? And I don't know if you wanted to maybe comment or touch on that, because I mean, it's a moot point, right? Independent or falsification is independent. Falsification is independent of replacement, as you say. They don't have a cause either for what's running everything, right? They like to think that they do, but obviously they don't, or else their math would work. But I just didn't know if you wanted to, maybe speak to that on the side of geocentrism.
Yeah, I was reading, but I think I did actually follow. I want to make sure I followed your question. You're asking the specific, like the causal mechanism of how everything is basically what's running the whole system. Is that the
Well,
question? Like,
yeah, well, we wouldn't know, but I was more to just speaking to how, even though we don't have a definitive answer, they don't have one either. So it's kind of hypocritical for them to not accept our
oh
stance
right,
without
yeah,
having one, even though they don't either.
yeah. We have superior speculations though. So like, if you had the entire universe, so obviously you have the first question, which is like in the idea that the Earth is not moving, but the whole universe is moving around it, you would ask, well, like, what made it move? How did it start moving? So it would require a primary mover, right? It would require something being entered into the system, introduced to the system, or the system actually being created in motion. Either way, it would require some type of primary mover. This is a logical and philosophical and intellectual prerequisite of any cosmological model, obviously. So we set that aside, like that's basically a question about God, but now, if you have a rotating universe, what happens is you have this immense universe, and if it's even just a fraction of the size that they claim, which I think it is significantly smaller, it's still a huge expanse, right? Like just go look at the stars. With that light pollution, you'll see that there's a huge expanse of stars. You have the whole cosmos rotating around a stationary Earth, and obviously, the further away you go, if it's maintaining angular velocity, it's going to have a greater tangential velocity the further away you are from Earth for it to all move together. So we're going to start getting crazy speeds. And so we have this huge universe moving around a stationary Earth. So what that does is it creates a few real inertial forces. It's like if you take a rope and it had something tied to the end of it, you start spinning it around you. It's going to generate real forces. And obviously, one of them is centrifugal force. So say you tie like a ball to the end of a string or whatever, it's gonna have the tendency to want to go out away from you as you spin it. That's centrifugal force, of course. And then you're also going to have the less talked about forces, which they try to claim like centripetal force isn't really real, but a real Coriolis force. And so that's just an inward force. And with all the immensity of the universe spinning around you, that force would actually be twice the magnitude of the outward force. So, long story short, you would have inertial forces, predominantly centrifugal and Coriolis forces, and that's going to create a net radially inward force. And so, basically, you would have like a seesaw effect where you have the force that's pushing towards like a tendency out away from the rotational axis, but then a stronger net inward force that's keeping it balanced. And so, you would effectively move perpetually. The universe would just perpetually move with real inertial forces. So now we actually have a true dynamically viable cause to uh what can effectively amount to perpetual motion around the earth, because it's in this constant balance of effects. So to repeat that but much more concisely, you have real inertial forces with the rotating universe around a central earth, predominantly centrifugal and Coriolis forces. Coriolis force would be twice the magnitude of centrifugal force, but would give you a net radially inward accelerative force that would keep the universe moving around us constantly. That there would actually be a translation of forces and motion down to the earth, which is seemingly what we do in fact observe. So yeah, it's a far superior model, and in any like satellite equation that you find, they actually account for these inertial forces as if they're real. And so any actual modeling of the universe uses and accounts for these inertial forces, which in the current model should not exist. They should be pseudo forces, fictitious forces, not actual. They should have no real tangible physical effect. But, if you even invoke satellites, they use them. So that is a general introduction to the idea. And I think, of course, the causal dynamic mechanism for all the additional motion in the sky is magnetic in nature. But yeah. Who we got here? Cosmological crisis. What's going
Thanks,
on?
bro.
Oh, Piazza. Yeah, no problem, brother. Cosmological crisis. What's up?
Yeah, I just wanted to say thank you for your explanation on Earth Awakenings. And I was wondering if you could elaborate and give us your explanation on the toroidal with the hyperboloid and explain that. I think it was, hold on, let me sit up. It's kind of hard for me to talk sometimes. Anyway, I'm not good on the microphone. But anyway, if you could kind of elaborate on the hyperboloid, how the toroidal field works, just your explanation on it, if you wouldn't mind.
Yeah, sure. So, a torus field can be simply thought of like a donut shape. So you have a donut, and then you also have the inside of the donut, right? So, which is like a hole. So it's the best visualization of it is a donut and an hourglass. So you have the hyperboloid and the toroid being the donut, the hyperboloid being the hourglass. So you have the hourglass and the donut and the inside of the donut. If you were to
Okay.
draw a sphere around a donut, the donut would be the torus field, and then all the space remaining inside that sphere would be the hyperboloid. So you have centrifugal, the phrases that I use are centrifugal divergence and centripetal convergence, which
Yes.
are pretty simple because centrifugal means out from the center.
Right.
Centripetal means in towards the center. So you have a force there's a centrifugally divergent force. And so there's a force that's moving out from the center, looping back around, creating that torus field. So it just is constantly looping around, moving out from the center. At the same time, you have like a superimposed inward force. So you have a centripetal convergence at the same time. So you have the torus field and the hyperboloid, the toroid and the hyperboloid at the same time. So it's conjugate geometry. It's a conjugate geometric expression. So it's
Wow.
like two sides of the same coin, right? And it's just this beautiful geometric pattern that manifests within that, which is called the flower of life, where you get the golden ratios, where you get sacred geometry. And it's because
Right.
it's just the perfect field. In fact, I would say magnetism is the only one true field. So yeah, that's now obviously mainstream academia can't explain magnetism whatsoever because they're confined to the particle physics paradigm. But not being confined to that and understanding that there is an ether, then you're able to explain it. You basically have inertia in the center, and so it's like pure potential. The ether in its like state of rest is pure potential, and then the actual magnetic field would be spatial extension. Now I get like way more into it, but it takes a
Yeah.
lot of explanations. For example, like the magnetic field is actually the spatial extension, whereas the dielectric portion, which is the conjugate aspect of it, the dielectric field actually creates the magnetism. It's like different modalities of the same thing. You have ice, water, vapor, right there. It's all water, but you have liquid, vapor, and ice being three different modalities of the same thing. And so you have the dielectric, the magnetic, and electricity. Electricity being the hybrid of the dielectric and the magnetic. So they're joined at the hip. You can't have one without the other, but you basically have the portal to the ether in really crude, simple terms. That's the black hole in the center of the magnetic field. And so
Wow.
all of that energy that's creating the magnetic field is literally coming from like this black hole portal in the center of it. It's like a
Right.
portal and a tunnel to the ether. And a true understanding of magnetism, in my opinion, would not only unlock the keys to the entire universe and all of cosmology, but it would also unlock the keys to all of physics and energy, etc. It's kind of like the biggest hidden aspect of existence, and.
That's pretty awesome. So is that under kinematics or dynamics? I'm not really familiar with how those definitions.
Well,
I'm just learning them.
yeah, technically both, right? So the magnetic itself is dynamics, the magnetic
Dynamic.
force because that's a force is always magnetic. But the shapes that we're talking about, the geometric motions, the centrifugal divergence, centrifugal convergence, the hyperbole, that's actually kinematic, right? The motion, the
Interesting.
geometric paths, yeah, would be kinematic, and then the force itself causing it, the magnetism itself would be dynamic.
Awesome. Thank you so much for your time. Let's
Yeah,
give
brother.
a shout
And
out to the
I'll
Miswits. Yeah.
say
Go
again,
ahead.
say again.
I was gonna give a shout out to the Miswits and everybody that's on the panel. Just want to say God bless y'all. Good to see y'all up here tonight, supporting Witsit and supporting this movement. This was one of the most awesome experiences I think I've ever had. I've learned so much from you, Witsit, from Alan. I don't know where Toby went, but Sacred, yeah. Shane, thank y'all. Run Boston Bear, special shout out, PZO. New perspective. God bless you all.
Hey,
And I
brother.
just want to
Thanks for
say, I'm going to
sharing.
address the elephant in the room. I think that Mord Wand is that still Prime I hear conceding kindly? Kinda? Anyway, I'm going to sign off.
Much love, man. Thank you, man. Thanks for all the shout out.
Yes.
Shout out to the
Mo-
squad. I
Mord's
want to say
never
this one more.
conceded anything in his life.
No, I want to say this. I want to say this one more thing though. Like, dude, take all
Yeah.
that we're talking about with the torus field and the magnetism and stuff like that, and just envision that that's what the universe is. You know what I'm saying? Like the
Definitely.
Earth. And it's so funny
I know.
because when they started looking
Beautiful.
at cosmic microwave background, if you watch the principle and you watch all these people considering like, oh man, is geocentrism back on the table? And that would be like the evidence suggests. I have all these quotes from different astrophysicists and stuff saying the evidence suggests that there's like a void around the Earth. Well, that would be very interesting if we're centered in a torus field. There actually would
Yes.
be something akin to a void around the Earth. It would be the center of the magnetic field that is the universe, the overall torus field, and that's where you're going to start to get this divergence away from the center that they tried to claim that somehow it's accelerative expansion. You're going to get redshift proportionate to how far away you are from the Earth because it's this giant torus field where everything's diverging out from the center. And so we just seemingly live in a giant torus field. And then we have different levels. It's like a fractal geometry that then goes all the way down to the small scale. So it's actually very
Yes.
beautiful and it makes perfect sense.
Thank you.
Yeah, and check out the playlist I just posted in the Purple Pill on Wich's channel, his new segment that he's doing for his channel. And he goes into the kinematics and dynamics as well as the kinematic equivalents, very detailed explanation with lots of those quotes he's talking about. But that's where you'd find some more information.
Yeah, shout
Appreciate
out
it.
to you.
Y'all have a good evening. Thanks, Witsit.
Yeah,
Keep
you
up the
too.
good work. Oh, I have
Will
one more
do, dude.
question. What is the status on you going? Are you like still going to participate in that thing that's supposed to be coming up, or
Yeah,
what? Just
supposedly, man. I got my passport in the mail. I'm supposed to go pick up
okay.
my gear. I'm getting that back. I got a backpack in the mail the other day, so supposedly, yeah.
Wow. Okay. All right. Well, I'll be praying for you, brother. God bless.
Thank you, man. Thank you, man.
He's
All
got
right,
his Dora the
Crisis
Explorer
King.
lunchbox and everything. Boys, he's ready to
Yeah,
rock.
man. Yeah, man. The satellite phone, Starlink. It's a GoPro. Crisis King. What's going on?
Hey, how you doing, y'all guys? You can hear me okay?
Yep.
Right on. I just had a quick question that I listened to a lot of what you do there, Witsit, and I haven't been able to find the refutation for it unless you just covered it with the distance, angular perspective at the distance. But how do we get the sunlight on the bottom of the clouds? That was one of my
Yeah.
questions. And then I think that torus field that you're talking about that's around the Earth, I'd like to put forward a motion that we call it the Witsit field from now on, because the only reason I would even visualize that is because of watching your content. So I just wanted to say thanks for that too. Okay, thanks.
No,
We're in a Witsit
I
field. I
appreciate.
approve.
No, I don't though. I first heard it broke down pretty well by Kim Willard, the Ori hypothesis, and he pointed me to the father has electrical field theory, like Charles Porter Steinmetz talks about it, the dielectric portion, stuff like that. So not me, but I appreciate the sentiment. Um, yeah, so like if they envision that you have street lights and they're all 10 feet tall, and then you look down a pretty long street and the street lights are going to look like they're going down in the distance right now. So it's going to look like the street lights further away from you or lower than the street lights closer to you, but obviously they're all exactly the same height. It's just due to perspective. And if you were to take like anything you could think of, like a trash can or someone just stands there, if someone stands halfway down the street lights that are way further down the street past them are going to eventually look like they're going down beneath them. right? And he's actually going to block out the light from those street lights, even though they're much taller than he is. The same thing happens with the sun. So we just see the sun where we see it due to perspective. As it drops down, we're going to actually perceive the light coming from that angle based on it converging into the distance. And then whatever's closer to us, it's just going to be lit up in proportion to that. It's just like if a perfect example would be to use the street lights and have something in front of it. And you would see that the bottom portions of whatever's shorter in the foreground would be lit up. You would see that something that's much shorter than the street lights would block out the much taller street lights in the distance. So, and for example, one of the things they like to bring up is the shadows that you see that look like they're angled up, right? So they're like, how could the shadows from the mountains be angled up to the clouds unless the sun's actually going down beneath it, and in the flat earth it's above it? Well, actually, when you get in a plane, you fly up above it, you see that those shadows are not doing that. They're actually going out horizontal away from the mountain, and that just due to perspective, it looks like they're angled up due to the divergent rays from the sun and your perspective. It looks like that shadow's going up. Once you get in a higher elevation in a plane and a higher altitude, you actually see that they're not doing that. So it all comes down to perspective. All right.
Wow, thanks. I actually felt my brain like wrinkle on that one when I with the street lights. I was like, holy crap, he's right. So I really appreciate that. Thank you very much for that.
Yeah, no problem, brother. Servant boy, what's going on?
Hey, how's it going, bro?
Good, man. How about
Uh,
yourself?
I appreciate your videos. You definitely woke me up to Star Wars not being real, and that was really sad. And the next generation not being real also, and that was really sad. That one hurt. Um, I know that in the past, I've heard you talk about God and stuff like that. Would you say that you consider yourself a Christian, or are you aware of what's going on there?
Yeah, so I do believe that the scriptures contain the truth. And so if someone point blank asks me, I'm not gonna run away from saying I'm a Christian. Like, sure, yeah, it means to follow Christ. I don't I don't identify with any mainstream Christianity, any denominations, any of the religion. I think religion sucks and is stupid and gay. I think that modern Christianity has been completely subverted and used to make people believe they need to be subservient to some group of people from Eastern Europe. So I denounce all of that. I denounce the idea of inherent supremacy and all this twisted nonsense from the Scofield Bible, blah, blah, blah. But I do think that the scriptures contain the truth. They're the most attacked compilation of texts in the history of man. And I've had like crazy direct spiritual experiences with it, direct answers. So there's absolutely like a true, personable, benevolent source, a creator that, as far as I can tell, directly stamps the scripture. So that would be my answer. Yeah, like Yeshua was real. Yeshua was absolutely crucified, and there seems to even be physical evidence that he resurrected with the shroud of Turin. I'm pretty convinced by that. So yeah, anyway, that's my answer. Yeah, I would say I'm a Christian in terms of follow Christ. I don't believe in any other religion. I say things that some Christians don't like. Like I say stuff like, well, in the book itself, it says you don't actually need the book. It says that creation itself shows you that there's a creator and that no man is with excuse. Um, and what did people do before that entire compilation was put together, for example? It's a personable thing. It's a relationship thing. It's not a religion thing. And it's clearly the modern Abrahamic religions have been used to completely subvert people and commit tons of atrocities and brainwash people and break them down into being subservient to Jews in Israel, if we're gonna just call it like it is. So, um,
Yeah. I just recently kind of learned about the whole false Jesus thing that all the churches are preaching. They've got it totally wrong, and they're rebuking all the heathens, which is actually forbidden by God. We're not to go and rebuke the heathen. We're supposed to rebuke the fucking church that is completely lost. They've lost their way. They don't know Yeshua. They don't walk in covenant. They don't rebuke. They don't fulfill the royal law like you're doing, you know. Holy Spirit has you fulfilling the royal law through creation, but it's the same thing. You're saving the lost sheep because the entire world is deceived, and that includes the church.
Yeah, I mean, I think we are to rebuke hedonism, but not. So it's like a tricky subject there, but absolutely the priority should actually be the church. It says that the people that teach and claim to teach on the behalf of the Creator are judged at a way more intense, higher standard than anyone else. And that's clearly the number one thing that he doesn't tolerate is people misrepresenting him. And yeah, the entire modern interpretation of the Messiah and the exclusion of the Father and all of that. It's a huge rabbit hole. I think it's all deception. Um, that's why I always I lead with it's much more about personal relationship, and I don't really blame people from if they've been deterred away from Christianity or religion as a whole, because I was the same way, and I still vehemently disavow religion. But I will say people should go and say, "Hey, there's so many different people and so many different ideologies making claims about you or who you are, if you exist, if you don't exist, who you are, and I just want to know the truth. And please show me, give me signs, give me a sign, an undeniable sign that you're real and who you are, and if you are the creator of the scriptures, etc." And you'll probably be amazed what happens. Um, so I'm a big advocate of like a personal relationship. But yeah, the church is gone, bro. The modern church is completely gone. We're told that would happen though. So, all right. Do we have anyone that's up here that has wanted to speak but wasn't able to?
I just wanted a real quick clarification before you guys move on. If that's okay.
Yeah. Man.
Yeah, so I've actually, like, come to think of it, I mean, heard about this a lot. The balance between like the centrifugal and Coriolis forces and a net inward force being created by the basically the mashup between the greater momentum further away at the higher tangential velocities that you were explaining earlier. But is there like, first of all, real inertial forces? Like, what does that actually mean? Because like the way that they define it, of course, is that an inertial force is not real. It's just like treated as a force because like in their uh, they do a coordinate system transform to put you in a stationary frame that's not really stationary, et cetera, et cetera. But what's a real inertial force, and then what's a Coriolis force in terms of a stationary Earth? Because like I'm just trying to wrap my head around like if this thing was put into motion, how it would be kept in motion, right? Because like on like a merry-go-round or something like that, right? You've got this velocity at the edge that's like greater than the center, of course, but I guess what I'm having a hard time like not visualizing, but in using my intuition to see where the perpetual motion comes into play there.
Yeah. Okay. So like centrifugal force is a perfect example of a real inertial force. Um, right. And so inertia obviously meaning unchanging, so it can basically be interpreted as like resistance to acceleration is kind of how like the mainstream will say it. But if you spin, if you tie a ball to a rope and you start spinning it, right, really fast, the ball is gonna want to head out away from you. And the only reason it's not going to is because it's connected to that rope. That additional force, that like resistance to the motion, the acceleration, because obviously the acceleration, it's rotational acceleration based on the central axis of you that's spinning the ball on the rope. It wants to go out away from you. And so in that sense, resistance to acceleration would be accurate, right? That's a real force. Like that centrifugal force is real. Um, so does that part makes sense. That's what I mean by real inertial forces. And when it comes to a Coriolis force, if you have like an actual entire rotating body, or like the analogy used by Mach typically was like a hollow shell. But if you had something truly rotating all around you, what would happen is whatever's in the interior of that would be affected by that motion, and the motion would be translated through it to you. And so when you're observing or anything from within there, there'd be a real physical difference. And including onto the earth. The motion would be translated down onto the earth, a real inward force based on everything that's inside of whatever is rotating. But in the globe paradigm, obviously, they interpret Coriolis as like a fictitious force that's it's just an apparent deviation based on reference frame. I think the easiest way to wrap your mind around a real Coriolis force is to YouTube a video of it. So there's like really good demonstrations that show you like real Coriolis force, like that's a real phenomena. And it's just been so like confused and diluted with this other idea of the globe Earth, the rotational globe Earth Coriolis force, where it's just fictitious and apparent based on reference
Ye-
frame, which is a totally different thing.
Yeah, it's always perpendicular to the. Basically, you can draw a tangent line to the outer surface of the disk as it rotates, so it's like perpendicular to the radial outward direction, wherever it's spinning. But then, the string is what's holding it in. Normally, without a string, it would fly off. But you're saying that the reason it doesn't fly apart is because the Coriolis force is overcoming it and keeping it compressed in, right?
Yes. Yeah,
Okay.
effectively. Yeah. And so this is
Yeah.
really where you get into like a debate, by the way, because they try to tell you centripetal force isn't real. I don't agree with that. But it's like whatever, like for intended purposes, whatever. Right? Like the phenomena attributed to Coriolis force is a real thing. Centripetal force is a real thing. And like that's why you'll hear Bennett say centripetal a lot. It's a real thing. If you ask, like, you look into like the mainstream paradigm, they'll try to tell you that centripetal is not a real force, but I vehemently disagree with that. Like, I don't even know how people say stuff like that. Um, and magnetism's a perfect proof that they both exist, right?
Yeah, and just
So,
for clarification, they would be a real thing if we were actually on a globe, but since we're not on a globe, yeah, they're not real in that sense.
That,
Unlucky.
that that's super interesting. Just thinking about like if I put myself in what are those spinny things that they have at the fair where like you sit on the inside of a spaceship and it spins and you like get pinned to the wall, but there's a guy in the center that's like operating it. He's fine. Like if that was the model of the universe, then the guy in the center would be getting crushed in like a freaking training chamber on Bulma's spaceship on the way to Namek type deal. You know what I'm talking about? Like he'd be getting compressed in the center just by the fact that there's all this mass spinning around him really fast. That's like that's how I'm visualizing it. It's like what causes that though? Why? What is causing a compression? It's like you have to have an ether there. You have to have a fluid even in that model. So that was a pretty interesting thought. It's like very. It's like unintuitive kind of, but I like it, man. Like I want to read more about Popov's work.
yeah,
Thanks
you
for the
should definitely
clarification.
check out Relational Mechanics by Andreas. He's like my favorite thing. Um, because I think he's like more on like what's actually going on, which is it's so confounding because he like makes a point to say he doesn't necessarily believe in it. He's just showing that this claim that you couldn't demonstrate a dynamic equivalence isn't true, and he shows it from both the Einsteinian and or Newtonian frameworks. And then he addresses real inertial forces. He addresses like the Coriolis and the pendulum, etc. So it's very interesting, right? But so
Wait, is
relational
that
mechanics, I think, is better. It's like I invoke Luca Popov a lot because it's a short paper and it specifically shows very quickly like this Newtonian equivalence and it's got the math in there for you. But relational, it's a little bit more extensive, the section where he covers this, but I think it's more along the lines of what's really happening. There's something that's kind of tangential in a way to Newtonian happening. It just isn't that it just gravity isn't what they say, and it isn't this innate magical property. And there's a mutual contact between objects and everything's has like intrinsic electric properties and stuff like that. But the Machian principle I think has like truth to it in terms of what's really happening in the universe, right? Because if you like, even in a simple way, if you just like, if you move your hand super fast over a bathtub, like the water is gonna move, and obviously, like, well, yeah, because the force that your hand generates, it's translated through the air molecules and then goes to the water. It's like exactly, there's a translation of the force down to the other medium. If there was a huge rotating universe, there would be a translation of that something like a rotational motion that we can't even comprehend moving around us. It's going to translate down to us. At the same time, it's going to generate a centrifugal force out away from it, right? And so both of those would be real inertial forces. If you spill over into their paradigm, it's not real. That's like when they in their satellite equations or even for their ISS equations, all this stuff, they account for the centrifugal force in the equations, but then they claim that it's fictitious. It doesn't actually exist. And so same goes for like the radially inward force. But and what's also funny about this is this used to be explained accurately even on like Wikipedia. It would show you the equations and explain that in a scenario akin to this, you would have a net radially inward force. It would be twice the magnitude. And once the principle came out, it got pulled off of Wikipedia and updated. So
Dang, you always got to be doing that. Shoot.
yeah, and just bringing that up to say like this was like an accepted understanding of physics until the principle came out. It's just wild.
Dude, I wonder if in the like globular geocentric paradigm, if they would see that net inward force as like something that would cause like a downward gravitic bias or not. It's interesting because I mean, if it's just always pressing in, I don't know.
Oh yeah, I think it's directly related.
Yeah, cool, man. Thank you.
Yeah, bro. All right, anyone else on the stage got something they want to throw in before we hand it
Oh,
over to?
before you guys move
I have one
on,
more.
I put a
I have one
link
more question.
to my Obsidian database that has some notes on fictitious forces and real forces and centrifugal and centripetal and what they mean in a geocentric perspective. They would all be considered real inertial forces, whereas in the heliocentric model, they'll say, "Oh, this is a fictitious force, but it has an effect." So they'll count the effect, and but they'll count the force as like fictitious, whereas they would be all real forces in the in a geocentric model generated by the motion of the sky. Anyway, continue on, lads.
Yeah, I would suggest that you be a moderator. If they're going to go into if Alan and Mordwan are going to do this, what's it? Obviously, you probably would do
Nah,
that anyway, maybe.
more it's
I don't know
fine,
if it's a
dude.
formal domain.
Oh, we'll be good.
No, he's a
All
good
right.
lad.
Yeah.
Okay. Yeah, there's a lot of conflation with the Machian principle and Coriolis and Sagnac and all of that, and they have to use those things, liberally to try to make up this idea that we're spinning, and then the whole idea with the atmosphere spinning with the Earth, but not really with the Earth, almost with the Earth, and lockstep, but not lockstep. And that's something that really just debunks the globe. We do not have the dynamics even in here. As we get closer to the Earth, Mordwan, you kind of just asserted that the dynamics weren't accounted for on our side of the argument when we get close to the Earth, when it's actually the opposite. But yeah, I'm looking forward to this, and I think Taylor wanted to say something still.
Tay.
Yeah, I had a fellow who was what's up? I had a fellow who was trying to come debate the science, and he said he was waiting for quite a while. I did DM y'all his name, so if he comes back, just let him up.
Oh, word.
And I do have one more question, if I could, for Witsit.
What's up?
Okay. Have you assessed any other type of models that have a direct intermediate kind of connection with the apparent sun that is connected to something maybe underneath us? Have you assessed anything like that? What's your take on that?
I mean, I consider something like that possible. I think that the data does show that everyone observes their own individual apparent sun, and kind of regardless of what you think, that's how we determine sunset time, et cetera. We use the equation of time and the apparent position. And some people went out and took like longitudinal measurements of the sun, meaning all the way down a longitude throughout the course of a year. And when mapped out on a plane, it shows like this individual apparent position of the sun for each observer that kind of, as you map out the whole sun with all those data points, it kind of breathes in and out, similar to a torus field. Like it creates a torus field. So I'm definitely very open to it. Yeah, I think that this place is probably significantly more complex than people realize. I don't make definitive claims about it though. But obviously, you're venturing over toward your question appears to venture over towards the idea of the black sun in the center that then projects out the sun and other
Right.
things. Apparently, yeah, I find it interesting, right? So I mean, in terms of like
Okay.
the magnetic
Thank
field
you.
and that being the central source.
Okay, just curious. Thank you so much.
Taylor.
Okay, I had a fellow who had a question here, if y'all don't mind. Okay, go ahead.
So I want to basically know everything that you're like teaching about gravity with it, and like where like what kind of terms do I need to search up to learn more about it? Because I had this question, and I don't know how to explain it. Like, why does like edema like collect closer to the ground? Like if you're on standing on your legs, and edema is like a excess fluid that escapes out of your vasculature and into your tissue, and so it can collect around your ankles and your feet and such. So why does that collect closer to the ground? And it's not really like a density problem,
Yeah.
because
So yeah,
Mhm.
yeah. So my understanding is there is a downward electric current on the Earth. It's measurable. It's 10 microamps per uh, meter squared. So it's really, really small. And you can run a generator off of it though. This is because we have equipotential. So to try to keep it really simple, like equipotential just means equal potential. So you have equipotential lines. So every say meter you go up, it increases 100 volts. So it's 100 volts per meter. It's equally increasing potential as you go up. And so what that does is it creates like a finite field and it equalizes and it basically creates this electric gradient. And then we have a downward electric current that goes to the ground. And this is why we ground things, right? Because everything is trying to make its way to the ground to discharge and equalize. And so I've actually done like different little experiments proving this. I've taken two Gaussian plates, created the same thing we have on the Earth, like this electric gradient, and put a little piece of styrofoam or iron filing or whatever in it, and it'll obviously just rest on the bottom plate. Once I hook up a Van de Graaff generator and I flip the electric field, the object goes up. And you can actually find the middle ground where you can make it levitate, and you can change how fast it goes, etc. So everything that exists is electric, all pieces of matter, so all the fluid in your body, it's all intrinsically electrostatic, because all molecular and intermolecular attractive forces are electrostatic in nature. So everything's electrostatic, and it's all within this electric field. And so you obviously have density, which is also electrostatic because it's the compactness of matter, and electrostatics is what holds the matter together to make it compact in the first place. But you also have the electric field and the object within that. So in like really simple terms, the reason things go to the ground is because all objects are interacting with their medium, and that medium includes an electric field. So we have a downward electric current towards the earth, so a slight downward electric pressure creating a downward bias. And so things are going to the ground to seek equilibrium. Another test I did was I took like 3 metal washers. I took some helium balloons and I wrapped the wire, uh, like the string around the washers, and then took some electrical tape and wrapped it around it while I had the wire coming from the Van de Graaff generator connected to it. And I balanced it just so that the helium balloons made the metal washers like levitate, like kind of float a couple feet above the ground. And when I would introduce the charge, it would go down to the ground because as it accumulated charge, it sought out the ground, right, to equalize. And so the reason that we have things with a downward bias on the earth is because everything's electric and there's an electric field and an electric bias. And that's on the smallest scale, 10 to the 36 power stronger than gravity's even claimed to be. On the smallest scale, the electrostatic force is 10 to the 36 power stronger. So the only reason that there's some other claim about gravity is because for the current model, you need something else there. They just kind of neglect the electric component. So that is my understanding.
Yeah, that's a super dope answer. I love that. And so, what's kind of the like one? I've seen some of your papers on here before. I need to go look at them again. because they're listed on your account. Like, how do I find like a paper so I could read more details? Like, what's the term for the like levitating the washers?
Oh, well, that's just a test I did myself. I think the video from that test is in the Level documentary, Level with Me, the last one. But if you want to read specifically about, like, say, the electric gradient, I always cite Richard Feynman as like a hostile witness. You have the Feynman lectures. I think it's 9.1, the Feynman lecture. So if you type in atmospheric electricity, Richard Feynman, you can read the paper about the electric gradient. It'll show you how everything has a bias downward. There's a downward current, and we have like parallel horizontal field lines. So that's a good place to understand the general concept of it. In terms of like the test I did specifically, I mean, I just did the test for the movie. Like uh, this is not going to be. There's a few papers I do have, which I can you can try if you DM me or have Taylor DM me. I'll try to remember to grab them. There are a few papers that have broken it down, like the electrostatic variable in terms of gravity or electrostatic gravity, but it's not popularly discussed because if gravity is electric or electrostatic, it doesn't work to explain their model. Like it wouldn't work to explain these supposed huge planets at huge distances moving around each other. So they can't use it. You know what I'm saying?
Okay, and I guess have you ever like do you got one plate to like float over the other? Like, what do you think about like objects levitating or being able to like use it as like propulsion?
Yeah, you absolutely you would be able to do that, but like say if something's really big and it has if it's really heavy, quote unquote, because weight is mass times gravity, mass is volume times density, gravity little g is just downward acceleration. So if something has weight, it's just volume times density times downward acceleration, right? Like the average rate it falls. Anyway, the heavier something is, the more electrostatics you're going to have to introduce to it to make it levitate. So when I was doing my test, I had this little Van de Graaff generator, but I was just putting little objects on the plates. So I was able to levitate it all. To say levitate your phone, you're going to have to introduce even more, right? It's going to be a proportionate increase. So to like levitate cars or people, like you would have to kill someone like 1,000 times over to make them levitate based on electrostatics. Um, so I do think this is what UFOs are, electrogravitic propulsion, and they've managed to perfect this and probably use like a resonance technology. But anyway, long story short, you can rest assured that you can do it because in physics, physics always scales, right? So like we know the principle of density is true. If I drop a ping pong ball in water or a golf ball in water, the ping pong ball is going to float, the golf ball is going to sink. Um, that's true. It would be insane for someone to say, "I don't believe that's true. Show me the world's biggest ping pong ball in the ocean," or "I don't believe it." It's like, no, it obviously scales. If we could actually create the world's biggest ping pong ball, it would float in the ocean, right? Because physics scales. So since we can prove it on the smaller scale, it would have to scale up. It's not practical to try to make things levitate, such as like cars. That's what people normally ask about is like levitating cars because it would take so much charge. So hopefully that answered your question. I was able to levitate it didn't matter what the object was made of, I could levitate it. It didn't matter what it was. It was just that it was small, right? Because if it was bigger, I'd have to have like a huge Van de Graaff generator. And once you get over a certain voltage, you can't even like commercially buy them. So blah, blah, blah. But hopefully that answers your question.
Yeah, that's absolutely awesome. And I guess last thing, if I can just ask another quick question, like, what's your thoughts of these equal potential lines having anything to do with like grounding and then maybe like our connection to the sun? Like one thing I hear, Dr. Jack Cruz talking about is how we should be in the sun, outside, I guess, as we always have been, touching the ground. And I feel like that has like something to do with this electrical field. If it's kind of attracting everything down to the ground, we should be sort of grounded, plugged to the ground and then sort of you know in the sunlight. Is that what's your experience with that, or do you think that has any connection to what you found?
Yeah, so that's pretty interesting, right? Because like when you get into, for example, solar power, like all the companies that make it, they'll tell you they don't really know how it works. And um I think that even the non-visible spectrum of the sun can transfer into electrical storage. So I do find the sun very important for many reasons. And there may even be like a spiritual component to it, but I do know that the sun is very good for you. And it may have something to do with the electric nature because the non-visible spectrum, as well as the visible spectrum of the light, is probably designed to interact with you biologically and anatomically, right? And then grounding is because we live in this world where people's bare feet almost never touch the earth. You're always wearing rubber, you're walking on concrete, you're in your house. And so you basically build up all this charge that you end up having excess charge. It people refer to it as dirty charge. And so grounding basically allows your body to begin to equalize. So yeah, I mean, you may be familiar with this, that you brought it up, but obviously people have done blood tests and looked at people's blood before and after they grounded, and coagulated blood will actually clear up. It'll actually begin to disperse once you ground. So it's like incredible, and that's because obviously you have all this excess charge, and so it's holding your blood together. It's not allowing things to move around freely. Um, so yeah, like the question specifically, how does it relate to the sun is a pretty profound one because you're getting into what exactly is electricity, what's the non-visible spectrum of light doing, how does your body convert it? And I don't think we actually understand the machine that is the body enough to truly know how it's interacting with the sunlight and converting it into electricity. I'm sure that we are the most efficient solar panels ever known to man, and we just haven't figured it out yet. But who knows? Who knows? So yeah, I do think both of those things are obviously like pillars of health, though.
Yeah, absolutely. I think that we're really tapping into something that is going to rewrite textbooks in the future. I'm not joking. You're right. We are the most efficient solar panel, and I can tell you why. So our mitochondria, like you hear powerhouse of the cell, it has these like chromophores which pick up the visible spectrum light like really well, the spectrum that the sun makes. And that creates electrical potential across the mitochondria and drives it, creating energy for our body to use. And I haven't really understand exactly how it works, how the sunlight on our body connects to the grounding yet. I'm still kind of working on it. But then when I hear what you talk about equal potential lines, in the being the source of gravity, I'm like, man, there is a whole nother reality that we can't even see, that's truly just put like designed by God, and we'll understand one day it's just totally perfect and amazing. And I think that, you're doing a really wonderful thing about, what you're teaching and studying.
Oh, I totally agree, man, and I appreciate the kind words. Um, all right, who else we got here?
Notice the
Uh,
medically charged questions from somebody in the medical field. Like I'm thinking like they're probably thinking you're crazy asking about edema in terms of gravity. Like, but that's how like your mind works when you're studying medicine. That's all you can think about. Like, why does the blood flow down? But
no, I
anyway,
totally put it
it's
together because
pretty
I remember
cool.
you saying what you were studying.
Yeah.
Yeah. Um, all right, biblical Earth. What's going on?
Hey, how's it going? I
Good.
uh, I have a quick question. I really wanted to say thanks. So I've got into this with a flat earth, started watching all the debates and all the stuff, and it is so.
Hey, bro, your mic's cutting out, bro. Your mic's cutting out.
Yeah, I got really muffled, like you were like talking into your jack or something.
Just for clarification, your mic was perfectly clear, and then it seemed like it went under a pillow. So just make sure it's unobstructed.
Is that any better?
No, now it sounds like you're like 100 yards away.
Perfect. Is that?
Oh, you were
Yeah,
perfect for 1 second.
you had it for one word.
All right.
Nope, back in the pillow.
No.
Oh my gosh. All right. Well,
Oh,
I'll drop
perfect.
down.
There it
Thanks.
is.
Oh, there you
Good,
go.
good, good.
Oh,
Nope,
no.
nope. Okay.
All right.
All right, maybe next time, man. Maybe next
All
time.
right.
Sorry, bro.
I'll tell you this much: if you're on a phone and it's Bluetooth, switch to speakerphone or regular, or hold it away. Just try holding it a little farther away. Let's see.
Yeah, I am on both. I tried. tried it both ways, so
Oh,
I'll drop down. Thank you.
this is mildly acceptable.
Oh yeah. So
Yeah.
I have a question. I heard something the other day talking about solar days and sidereal days, and it kind of gave the example. Are you still hearing me?
Yes,
Yeah.
sir.
Okay, it gave the example of if we were truly orbiting and spinning, in the heliocentric model, according to the globe, the Earth would make the complete rotation on its axis every 24 hours. And what I'm wondering is, it said if it's true, this the daytime, I jotted it down so I could do it, and I'm wondering if anybody has like a visual of this, because I guess I'm a real visual learner. But it said if it's true that it was happening, the daytime and nighttime sides of the globe would switch every 6 months, and gave the example of being in New York at sunrise and that would be at sunrise in New York, and after 3 months, the globe would be 90 degrees from its previous position, and a quarter turn from the sun, meaning the sunrise in New York during the autumn equinox should now be at midnight. And then after 3 more months of 24-hour rotation, the globe would be on the complete opposite side of the sun, 180 degrees from the starting position. And so the New York sunrise in the winter solstice would be at 6 p.m., therefore switching sides. And I'm wondering if that's a true thing. I can't quite picture it, but it sounds right to me. But B, if anybody knows of a visual out there online or something to look at it happening, so that it just seems like that'd be a nail in the coffin, for the heliocentric model, if that's true.
I tried to follow you. It was kind of difficult because parts of it wasn't hearing. I think I've heard the general idea before, but I would also need to see exactly what's being said, to be honest.
Okay.
Does anyone else have input here or know exactly what he's talking about or know where visualization is?
I think I've heard of that, but yeah, I would need visuals and to read it over and think about it.
Is that something I could like copy and paste and put in that little like bubble right now? It says 67. I'm pretty bad at
Yeah,
technology.
drop it in the purple pill.
Okay, I'll do that. And thanks, you guys. I was saying, just it is so pointing. It highlights. I knew this matched the Word of God. And then when I started watching you guys in debates and all this stuff, it is such an alarming thing, and it's so awesome how you guys handle those people that are just so mean, so vile, the straw mans and talking down to you like they're better than you, and it's just awesome. So thanks for doing it. I know that's probably not a fun situation to be in time and time again. So,
Oh, thank you, brother.
all right, God bless you guys.
You as well. Better than veteran. Don't want to let him in. I thought I was gonna get a adverb. All right,
Just bust out into a little freestyle, dog.
Yeah, I thought we were gonna hear a little echo. All right, we got Darren Steven. What's going on?
Hey guys, can you hear me okay?
Yeah.
Yeah, cool. New headset. Yeah, so just two quick questions. The first one is around going back to basics around little g and electrostatics, and wondering why little g more or less doesn't vary with altitude, but by the time you've got to about 5 kilometers, your 100 volts per meter is down to like 6 or 8, and then another 10 kilometers it's down to less than 1 volt per meter. So the potential gradient of the Earth is not in alignment with what G does.
So if I'm on a mountain, right, then I'm still just a few feet above the ground, right?
No. This
So
is just with altitude in general. So actually, I'm not sure how little G varies when you're on a mountain, but if you measure little G in free space, it's definitely follows the expected
Well, when has this been done? You just said definitely, but
So the voltage
I
measurement's definitely been
ventured
done,
to
right?
say that that isn't true. That you don't actually know that.
The voltage measurements have been done,
Yeah, but
and
not
I
you're claiming that the objects are falling at the same rate regardless of altitude. Like, do you have any evidence of that?
not off the top of my head, but I know that there have been measurements of little g done with altitude. I'll find some, but I just wanted to
Typically
see
on
what
like
you.
a mountain though, that's what I'm trying. Typically on like a mountain or something. I'm not. I mean, I guess in theory you certainly could try to do stuff in like a plane. Now, obviously not going to accept anything that's claimed to be from the ISS, but of course, even in the globe model, they claim that there is technically a slight deviation with altitude. Right,
Yeah, because proportional to one
and
and a half
this is the
squared,
thing
right?
to this is the thing to understand though. There's not an expected there's not a great variance expected because the downward electric current is very nearly constant and it's very weak. And so it's just that the actual object itself is held together by electrostatics. Is within an electric field, it has a downward bias determining the direction. When the object has weight and it's more dense than its medium and goes down, it falls at roughly the same rate because there's a very nearly constant downward electric current.
But that's the thing, right? That with altitude, if the voltage gradient is decreasing, there can't be the same downwards electric current.
Wait, what? Why is when does the voltage start decreasing?
After about 5 kilometers, we're down to like 6 volts per meter. This is in free. If you go up away from the surface, after about 5 kilometers, you're down to about 6 volts a meter. By 10, it's down to 2, and at 20, it's like 0.1 volts per meter. It tapers off very fast.
Do you want to like drop the measurements that you're claiming in the purple pill?
Yeah,
Because
yeah,
from my
yeah.
understanding, that's not even the mainstream models claim at all.
Oh no, I think it is. I think it is. That the 100 volts per meter is only on the surface and very close to the surface.
No, I think it goes up like many miles. Like to the extent that I don't actually believe where they claim it changes because it's not verifiable. So I mean, if you have some measurements that counter to
Yeah,
that,
I have.
I'm happy to
I
look at
have.
them.
What's the best way to put it in this session, or do I just
There's a little
comment
purple
on
pill in the bottom right. If you click on it, you can just drop
purple
whatever in there.
pill? I'm on the web, so I don't know whether the purple pill's
Should
there.
be like a little purple box with a chat
Oh,
logo
the
in
chat
it.
icon. Yeah, gotcha. Right. Yeah, it's just not purple on the web. That's all. Yeah, in
I
dark
got a
mode anyway.
post I can share with this, like refuting what he's saying, but it won't let me share it for some reason.
Yeah, I just put the voltage gradient in. Some Japanese guys did it with a balloon, measuring the potential gradient with altitude. Yeah, so at about 10 kilometers, it's 6.8 volts per meter according to their measurements, and tapered right off to 0.8 at 24. But anyway, that's yeah. I'll find the information about that. Sorry.
No, that's all good. I'll check this out. I'll try to find the paper
Yeah.
this is from or whatever. I've
And
seen
the
that
last
measurements
one
not saying that.
is a bit quicker and more controversial.
Yeah.
How does relational mechanics tie in with flat Earth?
Real quick, Darren. I think you're talking about the gradient in the wrong direction. It gets stronger when you increase in altitude. You're talking about when you get closer to the surface? Is that what you were saying?
No, the gradient's the strongest near the surface, the potential gradient.
No, it's the inverse. It gets stronger as you get further away.
Yeah, increases 100 volts per meter. So if you go up 2 meters, it's 200 volts.
Yeah, the voltage increases, but the rate of change of voltage decreases. The gradient decreases.
Well, like I said, for one, that is the claim, and normally the claim I've seen based on the measurements is that it's many miles. And secondly, if you understand the concept here, it isn't really relevant because it's just that there is a downward electric current and that downward electric pressure sets the directionality. And then you have the density relationship of the object in the medium, and then density is intrinsically electrostatic. And so it's interacting with that electric field that now has a direction set, seeks equilibrium, and it's going to fall at roughly the same rate. You're saying that it's like significantly different. The downward electric current is extremely weak, and there isn't going to be any significant variance, uh, period. But I just don't accept those numbers based on the other measurements I've seen. This is the first time I've ever even heard the claim that as soon as 5 miles, it drops off significantly. That's not what all the other sources say. So, I mean, but I'm actually pointing out that it's non-consequential to my position.
Yeah, it's interesting. I have a fundamental disagreement with the fact that a small electrical gradient can result in a large acceleration. It can't just change the direction of things without actually creating a force of some kind. Yeah,
Well,
and
do you agree I can take two Gaussian plates, like surfaces, like plates acting as two Gaussian surfaces, and then I can flip the electric field and the object will
oh
go
yeah,
up?
yes,
Right.
because like you said before, you put a lot of charge on the things and you can generate a force, right? So your Van de Graaff generator is probably generating. So we've got 100 volts per meter at the surface on Earth. Van de Graaff generator is probably generating 1,000 or 10,000 volts a meter, or maybe even 100,000 volts a meter. Those things are normally kilovolt voltages over a few centimeters or a few inches, right? So it's a very high potential gradient working on
But wait, let's
highly
take let's
charged.
take this where this logically extends. So if I put a small object there and I can flip it and make it go up, what about when I put a little bit of a heavier object and I flip it but it doesn't go up?
Yeah, I can also throw something upwards, right? You can produce any force to counteract what's going on in gravity. That's all.
No, it's just flipping the electric field though. It's not like just the force itself is interacting directly with the object. It's not. It's interacting with the plates and it's flipping the electric field.
Yeah, so the electric field's generating the force, right? That electric field is acting on the electric charges, causing them to be subject to a force.
Okay, what direction does that force go?
The charge depends on the charge and the polarity of the field, right?
Right. So prior to me connecting it, there was a force going down. Is that correct?
Yeah, its gravity was probably pulling it down. Yep.
No, not gravity, man. It's not gravity because there was an electric field between the two Gaussian plates before I flipped the field because I'm manipulating the variable that's already there, right?
So can you start
I
again?
did I
Sorry.
didn't
So what was?
connect the Van de Graaff generator to air molecules. I connected it to two plates. So what happens is if you take the quote unquote negative and you put it on the top plate and you begin to spin the Van de Graaff generator, what it does is it flips it because previously the quote unquote negative, the discharging plate was in naturally on the bottom. Once I flipped it, now the object has a slight bias upwards, but the object has to be small to actually move in relation to that bias. So the field is seeking equilibrium relative to the two plates, right? Which plate is discharging, which plate is charging, and it flipped to cause the polarity of the field to flip, which now caused the directional bias to flip, and so the styrofoam and little iron filing will now go up. But prior to me doing that, it was just naturally going down. So I actually manipulated the variable that was already there, which is the electric field. I didn't like individually charge molecules. I didn't connect the Van de Graaff generator to the object itself or anything. I just flipped the electric field. If I put a little bit of a heavier object on there, although I flip the electric field, it'll still stay on the ground. And that is because the object is more dense. Because again, weight is mass mg, which is little g, so that's volume times density times downward acceleration. That's all that weight is. So it's that. So what is mass? Well, it's a conceptual quantification of matter, right? So volume times density. What is density? Compactness of matter. So what is the cause of density? Whatever is causing the matter to have a certain compactness, that's intrinsically electrostatic. So the very primary variable of the density relationship is based on electrostatics. Gives us compactness. It interacts with its medium. Like, that's all there is to it. The downward electric pressure is just a slight bias. The object's interaction with the medium is going to be significantly stronger than that. So the reason that this is always such a disconnect for people is they've always interpreted it through this lens of there being some force pulling everything down to the ground, and they're expecting a replacement of that claim. But I don't need that claim. I don't believe in that claim. You need that claim. You believe that we're, there are people antipodal to us and that we're spinning and all this stuff. But and that massive planets have to fly around each other at hundreds of millions of miles away. And I don't believe any of that. I
No.
don't need to explain any of that.
Yeah.
So what basically
Yeah.
happens is people impose false phenomena onto to us that we need to somehow replace because they have trouble separating the two. They conflate the two ideas.
Yeah. I guess your little experiment is interesting, but you could actually turn it into a proper experiment where you measure masses, charges, forces, and see what goes on, because it's well established what the force would be on a particular charge in a particular electric field like that. So that's easy to deal with. But that leads me to my second question. We can leave this for now, we'll go nowhere. Is you're talking about relational mechanics and geocentrism versus heliocentrism, and all of this stuff, and gravity and the like. How does any of that tie into flat Earth? Surely that would also, all these things also reinforce the broadly speaking, the globe model of our solar system at least, and the universe around us.
Why is geocentrism exclusive to a sphere?
All of these things that you're talking about, relational mechanics, so they're not going to work on a flat Earth either.
Why not?
Because they rely on things like the spherical symmetry of these fields, the fact that the universe is all around us, not just above us.
The universe is flat.
No, what do you mean by flat? This is talking
It's
about
flat.
the relativistic view of flat. That means it's Euclidean, not two-dimensional.
No, it's called no. The universe itself is actually flat. In your
What do you
paradigm,
mean by
it's flat. Like as in, if you zoomed way out of the universe, it's like mind-blowingly flat. So you just propose this idea that there's this huge immense universe that extends in all directions like a giant expanding sphere. That isn't what your model is. Your model is flat. The universe is flat.
My understanding of the flat universe was that meant that it's Euclidean or nearly Euclidean.
Well, this is a slightly different thing. Yeah, like to even impose your relativistic interpretation of the universe, what they do is they use like infinitesimally small Euclidean like portions and they stitch it together and then impose overall curvature rates exactly the way that they impose the presupposition of sphericity on the earth with geodesy. But that's not what I'm talking about. I'm talking about the universe is flat itself, like as in there's no positive or negative curvature. And this is a major problem. It's called the flatness
Yeah,
problem.
that's
Is because the energy density required to have the universe do that is 0.00701, and it's like considered a fine tuning problem because the statistical odds of it doing that are basically zero. So it's not just about relativity or Euclidean anything. It's about the actual geometry not having positive or negative curvature based on the initial energy density required. It's flat. The universe is flat. So now if we take that over here, we understand that everything is moving around us. This idea that it requires like spherical symmetry underneath our feet just isn't true. But then, of course, if you understood the concept of projections anyways, you would know that that isn't the case. So the answer to the question is that geocentrism is not exclusive to sphericity in any way.
so. How? Well, I think you're going to talk about this with Maud one, so I'll let you go. But yeah, I've got a dispute that a projection is equivalent to a simple coordinate transformation. That it changes the geometry of what you're looking at, so it can't be equivalent.
Well, they are different things, of course. Yeah, coordinate transformations and projections are different things. But the reason that I don't go that far into making that claim is that it would be ignorant to do so because I don't claim a definitive map. And if we were lied to about the nature of the Earth, the very last thing they would let you do is know exactly what the map is. And to answer your initial question, like what does it have to do with flat Earth or how does it help flat Earth? There are two primary claims, which is one that the Earth is in motion and one is that the Earth is a sphere. You can flip flop those, say the Earth's a sphere and that it's in motion. They're two separate things. What I've found is that people are so intellectually dishonest about the geocentrism component and the the actual superiority and viability of the geocentric models, any type of geocentric model. They're so dishonest about it. The mainstream's so dishonest about it. The textbooks, the schooling system, the education system, the propaganda, all of this using big tech to censor the alternative positions. Mainstream academia is so dishonest and excluded. When you dig into their books and their writings and their papers, they say, "Oh yeah, it could totally be geocentric." It's totally lied about, and all the people that come to debunk flat Earth or whatever, argue against it, they always want to skip over it, and they treat it like a package deal, like that either flat Earth is true or the heliocentric globe model is true. And what I found is if I can't get someone to level with me and have an intellectually honest discussion in good faith about geocentrism, there's a 0% chance that they're going to be open-minded enough to discuss things such as geometry or not having a map. They can't even accept that they don't have a proper dynamic explanation for their own heliocentric model, and that we don't have to replace it, and that there's a equivalence within their own paradigm. Then, like, why would I talk to them about something that we have to be honest enough to acknowledge we don't have answers to, like what's beneath our feet and stuff like that. And the other big thing is what we're really dealing with is people are terrified of not fitting in with the consensus. That's what this is all about. Like, no one wants to be the person that says they don't believe the solar system is real. They don't believe the current model of the universe is real. They are terrified, like mortified of the idea of not fitting in. And so that's why people always avoid the arguments about geocentrism and jump to flat Earth, because it's a tactic to avoid ever having to actually address the possibility that the current model is wrong. They have to keep it all together. So that's why I lead with geocentrism. That's why I basically refuse to go too in depth in the flat Earth geometry portion of it until people are honest, because it's just a futile pursuit. If someone can't be honest about geocentrism, they're not going to be honest about flat Earth.
That's fair enough. Could you also conceive that we could make a lunar-centric model of the solar system and universe? It would work just as well as a geocentric one.
I can conceive of the idea in your paradigm, and I vehemently disagree. In fact, the only one viable in terms of both kinematics and dynamics is a stationary Earth, and we require a stationary lab frame to do all of physics. And stuff like Ares failure proves that it's the Earth that's not moving. So, no one's ever going to rebut Ares failure. We will all die waiting. There is no rebuttal. And no one even tries to. They just want to ask me how do eclipses work. Whatever they can come up with to avoid addressing the evidence that the Earth is what is stationary, and it's been empirically proven with something as simple as water in a telescope. Something as simple as water in a bucket proves it. And this is again just kind of reiterating the point, which is like until people can be honest, like, why would you not look into that? Like, if there's a claim that the Earth is moving through space and that causes stellar aberration, so it causes the light from the star to come in at an angle. So to keep the star in the middle of the telescope, we have to tilt it because it's the Earth moving underneath that starlight. Just like if we were running in rain, the rain would look like it's coming at an angle. So then, like, oh, okay, well, if we put water in that telescope, it's going to slow the starlight down. It's going to take longer for the starlight to get to the telescope. So if the Earth is moving underneath it, once we add water to the telescope, that's actually going to increase the angle, because now we're increasing the amount of time that the Earth is able to move underneath the starlights and increase the difference, the distance between the two. The angle is going to increase. When we actually put the water in the telescope, it doesn't do that. So that is a direct physical refutation. That's physically impossible if it's the Earth moving. Now the only explanation is that the Earth is not moving. And I cannot play these games anymore after 7, 8 years where people want to ask me what's underneath the flat Earth, where's your map, which are bad faith questions, when someone can't address water in a telescope. So that's why I've been focusing on geocentrism. I've discovered that it just saves me time, and the rest of it is just all tactics. So I'll tell you, if anyone's actually wants to know the truth, they would refuse to believe that model still until they could answer Ares failure, until they could answer Michelson Morley. Anyone that's truly pursuing the truth. That's not what people are doing. What people are doing is desperately looking for a way to protect their current belief system. So now we're dealing with like a ideological issue, a philosophical issue. We're not dealing with what is true. So I'm very calculated as to why I discuss geocentrism more now.
Yeah, I guess there's not much strong evidence around measurement of flat Earth and stuff like that, and I see this as a diversion away from the nature of flat Earth. Things like GPS and even if you want to work out what comets do in the solar system, not that you believe that thing even exists, as far as I can tell. Don't want to say what you believe and what you don't believe. Apologies. Even simple things that are often floated in these fields, like the fact that the sun doesn't change its size as it moves across the sky, but
You
yet it's
totally
subject to.
just evolved. You totally just evolved and little backhanded slights and focusing on flat Earth and even straw mans of it and mischaracterizations of it. You literally proved
Dude,
my
it's
point.
it's like he did the thing you
Yeah,
just
yeah.
predicted, bro. That's so
I know, that's what I'm
crazy.
saying.
Yeah,
That's what I'm saying.
it's well, I guess it's frustrating that I want to understand
Nah, it's not. Wrap it up,
the
B.
flat Earth
It's
view of
frustrating that you
things,
guys are
right?
scared of the Earth not moving. I
Yeah.
agree. It's so gay.
Oh no, I'm not scared. Because I
You
know
are
that it's a
literally
globe.
scared of it. You're
I've
scared of it,
done
bro.
my own measurements, right? I've
You
verified
done
how
measurements of the
GPS
Earth
works.
moving?
No, of Earth moving, that's a more difficult thing, but I know it's a globe, and
But do
whether
you
it's
not see
moving
my
or not
point?
is
Why are
a
you so scared of it not moving? Why did you feel the need to, once I really laid it out, you're like, you know what? I gotta make Austin look stupid. I gotta try to attack him
from.
personally. I
Yeah, that's
gotta
fair enough. I
impose
shouldn't have done that.
dishonest intentions on him right now. It was an emotional response. It's because when I really lay out the situation with the earth not moving, people get uncomfortable. And like, yeah, oh, there's no physical measurements of flat earth except engineering ever has literally used a flat Earth, and you believe, well, sure, it's got
Well,
to be used flat for on the local scale. But then you say stuff like, "There's no measurements." We created the latitude system with a flat Earth. We fly planes with a flat Earth. We do civil
no,
engineering
we
with the flat
don't.
Earth. We make plane survey measurements with the flat Earth. We built all maps with the flat Earth. Your stillman position is, yeah, we use the Earth as if it's flat for all practical purposes on the local scale, but due to scale, it actually is a sphere and can be used as if it's flat. So the intellectually dishonest position is to claim, oh, there's no evidence that it's flat. There's no measurements that it's flat. It's like, what? Your
Hmm.
model requires the flat Earth measurements, literally,
Yeah,
literally.
and I guess that's why sometimes it generates an emotional response, right? That those
Nah,
4 or 5 little
it's not
things that
why.
you
Are you done
that
yet
you
or
quoted
no?
before, right? Around like, we need all aircraft flight is based on flat Earth and things like that. That is factually incorrect.
Will you explain to him what's it? Just explain to him. Planes do not work on a spinning ball when the pilot is
Yo,
treating it as stationary. Come on, please do.
yo,
He can't even address. He
I
can't
already
accept
kicked
that it's
him.
flat, bro. Yeah, come
I
on. He
already
can't
kicked him.
accept that it flies over a plane, bro. This all just doesn't matter.
Well, by the way, his whole I don't like that's such an incorrect claim about the electric field. Like, dog, I just posted the Feynman lectures from Caltech, and they show it like, you know, averaging 90 volts per meter up to 50 kilometers. So
Yep. Yeah, I didn't make a claim because I couldn't remember if it was 50 miles or 50 kilometers.
yeah, I mean 400,000 volts at 50 kilometers. So yeah, he was just
Yep.
wrong.
Yeah, and then when you actually look at so we hear the 10 microamps, and it's like, oh, it's pretty small. But if you actually look at the total amount, and in his lectures he talks about the total amount, it's pretty insane. And all of a sudden, this idea that there's like a downward bias on the Earth is like, no duh. Do you know how much like electricity is around you, bro? Like there is such a huge electric field coming down to the Earth. Like, of course, there's a downward bias.
Oh, dog, by the way, yeah, so I'm doing, formal physics electromagnetism stuff right now. And I was like, I realized something the other day. It's been a couple weeks, but I did it in my notebook. I've got the calculations. I can share them with you offhand later. But I was like trying to figure out if I could use like all the capacitor equations and electric field equations to determine the height or like the altitude of the firmament. Turns out that you can't, but you can roughly estimate the charge of the upper plate, right? Like if the firmament's the upper plate. And I did some rough hand math just using rough estimates of, the size. It's about 450,000 coulombs, give or take. So if you know how much charge is in 1 coulomb, it's a lot of charge. Like, that's a lot of charge. You put 1 coulomb really close to 1 coulomb and make them collide, it'd like blow your room apart, you know. But
Yeah, that's crazy. That's crazy to think about.
yeah, there's a lot of charge in this guy. Anyways,
That's why I don't think
funny.
you can get. You're not getting through it. So
They even in the Antarctica thing, bro. They show like it's like supposed to be like a dumbed down version. It's not grad level. It's like high school, entry level, college level stuff that they made. But the Australian Antarctica government website has this image that Alan shared to the space where they have ionosphere and then Earth's surface, and they're drawing like a curved ionosphere and a curved Earth surface, and then field lines, and saying that it's a parallel plate capacitor.
yeah, that's literally not possible on a sphere. Like I don't.
Right. It would be radially. It'd be a radial capacitor equation, not a parallel plate one. It'd be the square of the distance.
Just using the old parallel plate equation and not the one that dissipates over r squared. Nothing to see here,
Right.
folks.
Right. Because then it would be a concentric shell capacitor or concentric sphere capacitor, and yeah, that wouldn't be two plates, because two plates only works when, you know, they exist as like two parallel planes. When you have one plate like crossing over the original plane that it created, it doesn't work like that.
Hey, I have two people trying to come ask a science question. One of them is MW. He's got like a yellow profile picture, and then another one, Braden BT, about magnets or something. Yeah, if y'all could let him up, that'd be really cool. But I did hear something pretty interesting earlier that I've never heard before. Like, how would the star trails make a full circle at night if like the Earth makes a rotation like in 24 hours and it's only nighttime half of the day? I don't know. Maybe I haven't thought that one out all the way, but I just heard that earlier and I thought that was pretty interesting. They have some stars that make like a full circle.
Yeah, that's an interesting thought, Taylor. I'm going to drop down to give space for more people to pop up. Thanks for this, What's It? I'll be listening.
Hola. Yo, do you want to get to Lily real quick and then we'll get to whoever the new people that just joined? Our boy Braden.
No, my hand was not up. I think that's just a malfunction.
Oh, it's just an aberration. Cool. If I measure the angle of it and ratio it to the speed of light, am I going to find out you're moving at 30 kilometers a second, Lily?
Well, all I'll say is whoever that guy was, I guess the Australian guy, I can't decide if his type are like just genuinely dumb or they're just, being malicious. And it's hard to tell.
Well, it's like he's a good dude or whatever. We had a good conversation once, but then when you reach the point when you give up, you just like start shit posting, and like that's all that was. Like he just gave up, and then just, instead of just graciously saying, "Well, thanks for your time, man, appreciate it," and dipping, he was like, "Hold on, let me just shit everywhere and defecate." So,
Yeah, there's a level of shamelessness, I guess.
tomato, as they say. But anyway, welcome, Braden and MW.
Thank you. Can I ask my question?
Absolutely, good sir.
It's kind of hard to hear. I don't know why it switched, but it switched to like phone mode, so I have to put my phone in my head. So quick question. I like to think, like you get in depth about things, but you also got to think about things simply. So my question is, if we like just take the magnetic declination and straighten those lines out, do you think that that would create a more accurate map? Because from what I'm familiar with magnets, they're pretty like consistent on how they work, are they not?
about like the field lines.
Yeah, like so if you go to like Antarctica or you go to like well just all over the map, the compasses they don't work correctly and you have to account for magnetic declination and it seems to um, be problematic within the zones in which they have changed the size of maps. We already know that they changed the size of maps. The top is expanded and the bottom is, or the top is expanded and the bottom is shrunk a bit. If we get rid of that magnetic declination, do we think that maybe we would get a more
You cut out a little
He,
bit at the end there,
he,
but I
he
assume
dropped.
the rest of the question was, would it be more accurate to straighten those out? I have no idea, but I'll bring you back up.
Yeah, the magnetic situation is pretty complex, right? Because there is a difference in the true geographic north and magnetic north, and it deviates and it changes. And I have reasons why I think that that is, but when it comes to the magnetic field lines, it's all based on relative proximity and what compass you're using, and it's a pretty nuanced conversation. So to like truly map out what's going on in the South would require like lots of resources and expeditions and proper readings and stuff we simply don't have access to. You know, what's funny is like my wife come up here, tell me good night, and then all of a sudden like it just kicks me out of the space. I'm like, wow. And I guess just to clarify, so when I came back, it said like the space will end soon. So is that what happens when it says like the host is experiencing connectivity issues? Then you have a few minutes, you have to jump back in or it'll end. Is that how it works?
I think so. Never experienced it, but that's what it sounds like would happen.
That is what happened to me. It said the host is experiencing connection issues, and then it went to instead of going to speakerphone, which I don't even know how to make it go to just like the earpiece mode, but went to earpiece mode and then kicked me while I was talking.
Okay.
Yeah, this app is DS, man. It sucks. It does all kinds of weird stuff when you go from listener to speaker.
So sorry, I didn't hear the direct answer. Do you think that would give us a more accurate map or no?
I think in theory you could move in that direction. I just think it's not realistically feasible based on what would be required to properly map it out in the South, was my answer.
Okay, gotcha. Also, don't need to go too in depth. I know sometimes you don't like talking about it, but is that Antarctica thing still happening, and when would that be?
Yeah, I think I'm supposed to fly out the December like 11th or 12th, and yeah, as far as I know, I'm supposed to go pick out all my gear like tomorrow.
Nice, that's exciting, bro. I'm happy for you, bro. I've been watching you since you were doing the tour with that other guy who's shady guy, but it doesn't matter. Without the tooth and all that stuff, man, it's just been really cool. I think you're gonna
Yeah.
become like you're gonna be a legend, bro. Like you're gonna go down in history books. It's awesome.
I appreciate that, bro. It's funny you saw me with the chip tooth.
Oh yeah, bro. Trust me. I've been following.
That's funny, bro. Yeah, for those that don't know, so when I'm gonna tell the story. So when I was young, I was like 11 or something. My uncle, he was like like spinning this metal pole, like kung fu or whatever, and was trying to scare me. And so I was showing him that I wasn't scared. So I was just staring at him like I wasn't flinching. And he acted like he was gonna hit me with it, and it slipped out of his hand and hit me in the tooth and like broke my front tooth. So then I got this like little half fake tooth thing put on or whatever. And then like a few months later, I was at recess and I struck out in wiffle ball because I was like being cocky. So I was so triggered that I actually struck out that I threw the bat up in the air and then I looked up to catch it last minute, hit that same tooth and knocked it out. I got it fixed again. And then I had that fake tooth my whole life into like my mid 20s or whatever. And then I tried to take a drink of Jameson really quick, and the bottle hit my tooth, knocked it out. And then this is gonna sound so weird, but I was like, you know what? I'm gonna prove that I don't care what I look like. So I kept a chipped tooth for like a long time, and then I just started like letting my beard grow super crazy and stuff. So when I went on the tour, I just went around the whole US with like this like crackhead looking missing half front tooth. It's funny. That's what he just mentioned. It's so funny.
You had a chipped tooth on your shoulder.
Yeah, I had a chipped tooth for so long. Anyway, it's like like guy was like, yeah, I'm not gonna lie, it's not a great look for flat earth. You're like you're trying to tell people that the earth is flat. You look like a crackhead.
Dude, I'm not even joking. Like, I'd show people videos. They're like, who are you listening to? This chip tooth motherfucker. Why wouldn't he get it fixed? Like, what is going on? I'm like, just listen to what he's saying, bro. He's smart, dude. He knows what he's talking about.
And you could I totally could have got it fixed for like a few $100, and it's like I don't know. I will say though, this is why I'll be very transparent. So back in the day, I used to drink and smoke and like uh I had like somewhat promiscuous past. Okay. So then I had like a super spiritual experience, and I started kind of like crazy spiritual experience. And I won't tell the whole story, but it was like crazy. And I did what I tell people to do, which is like just say a honest prayer, be like, yo, show me if you're real and give me undeniable sign. And then I started getting like very real undeniable signs. And I'm like, okay, this is super real. I need to chill. Long story short, I started feeling bad about like drinking and smoking, things that I considered very petty, right? Like I'd smoke Kush all the time and I'd drink Jameson and stuff like this. And I'd cuss and I'd hang out with girls. I started feeling bad about those things like instantly, which is wild. And so I stopped doing it. And then I started like kind of being tempted to go back to doing it. And the house I was staying at, like people would come over and girls would come over and all that stuff. So um, this crazy opportunity came up for me to like move out, and someone was like, "I just bought this really nice house I'm gonna build on top of, and if you'll just live there, like take care of the 5 acres, you can live there for free." So I'm like, "Okay." Anyway, all that to say, I didn't fix my chipped tooth because I knew it would help me kind of go celibate. So that was like one of the main things. I was like, I'm gonna prove I don't care what I look like, and I'm gonna just like look crazy, and I'm just gonna have my little like moment in life where I just like dip off. So anyway, it worked. It worked, bro. Good luck trying to walk up to a really attractive girl, with your your front tooth chipped.
Dude, 100%. Even what you're saying about the spiritual stuff, like you saying, like, dude, just pray and say you want to see some shit. Like I did, and like, dude, I've grown up in the church my whole life. Like my father's a minister, and I watched people like praying, falling on the ground, all this stuff my whole life. I didn't feel that stuff personally. I did the good stuff like in the streets. Like I was always feeding homeless people, this, that. But I really wanted to feel it for myself. But when you said like, dude, just it's like I was just watching a video. I don't know how you worded it. It was so long ago, but you're like, man, I had these experiences. All I did was just say like I want to dedicate my life to this stuff, and like I want to see if it's real. I did that, and like, dude, a year straight, man. I just started getting hit with things, and like I like um I had a few other buddies. Like I used to be part of the bear groups and stuff, the meetups in person. And one of the guys there, he goes, dude, I used to do all that stuff too, drinking, smoking, girls, all that stuff. He's like, if you want to take it seriously and pray about it. And he's like, I did, and God told me to stop doing that stuff. I stopped doing it for a year. I got a virgin wife. I got a house. I got a kid now. Like he's got 3 kids now, and it's only been like 2. I don't even know. Like he pumped them all out. You know what I mean? And he's having a great time. And I don't necessarily have a wife or anything yet, but everything is getting a lot better for me. Ironically, I my leg actually stopped working. So I kind of got sat down. I don't know if I would have stopped everything if it didn't happen like that, but dude, this period of like a year and a half that I've been like not able to walk has been so eye-opening for me. And I don't know, I don't think it would be that like most people would think of this as like some garbage time, but dude, I've just been spending it all focusing on finding the truth, knowing the truth, and me being away from all of those people that were so easy to be around has been so eye-opening because I realized I was just doing things because like a bunch of people we're saying to do these things, and oh, this is normal. And then I step back, I'm like, I don't even like this shit, man. Like, and now I only do what I want to do, and I still go out with friends and stuff, but I don't drink. None of them even care. Like, that's one of the funniest things is like, I'm encouraging my friends to not drink anymore, and they don't even care, and we still have fun, and I don't know. None of that stuff is important. Anyways, I don't want to keep away from the discussion, but yeah, like you've been really, I don't know, a good role model in a lot of ways, and I don't know, we're not that far in age. Like I'm 28 too. I don't know how. I think you're only like 30 or something, but yeah, it's been really good watching you and learning from you a lot.
No, that's cool, man. I appreciate that more than you know, brother. Um, and you have a good testimony, man. You're supposed to teach tell other people about it. I think you dropped again, but yeah, like it's funny because Owen was a big part of mine actually, which is very interesting. Everything comes kind of full circle, but yeah, and, hopefully, maybe someone that hears this or is in here or hears the replay needs to hear that. Dude, I promise you, bro, it's super real. There is a creator that is just sitting there, and the creator is real, dude. Like as real as anything in the world, and is like personable. So, like, really wrap your mind around. That's pretty crazy. There's a creator that's personable and is able to like have this intimate personal connection with all the people it's at simultaneously, right? So it sounds like insane. It's totally real, and it's more real than anything you can imagine. And once you're like feel like you're truly embraced by that, it's like you're invincible, and you'll have these moments where you start to get frustrated because, like, dude, my life is like a movie. Crazy stuff has always happened to me, and you'll have these moments where you're reminded like the creator's there and you just immediately feel like invincible. It's a very empowering thing. I definitely encourage people to check it out. So, but we won't have to go all into like the spiritual thing. I know some people, you know, it's not their thing or whatever, but I am just encouraging people to check it out because if it wasn't for me hearing other people's sincere experience, I wouldn't have necessarily done it myself. And bro, I have stories that would blow your mind. It's 100% like life changing and very cool. So, um, yeah, there's that, and that's actually why I do this. So anytime that it kind of comes up, I'm gonna take the opportunity to say some things. So hopefully someone considers it, and and I'll even say this. I think that it's okay to kind of like challenge the creator in that sense, as in like show me. Like, he's not like think about it, if there's a real creator, do you think he is offended that you wanna know he's real? Like, no. So, like, just say, like, "I wanna know if you're real." Like, give me an undeniable sign and know what you're asking for. You're asking for a creator of all things to, like, intervene in your life, right? And so just know what you're asking for. But okay, sermon
What can
over.
I ask one last question before I go?
Yeah, yeah.
Okay, so like you said, my testimony should be shared or whatever. I've been trying to. So for 2 years, I've been saying I'm going to put out videos and speak about truth and like try to like raise people's like I don't know like conscience basically. Do you think that I should just start it? Like I'm so picky. I'm like, oh, this isn't right. This isn't perfect. Blah blah blah. Is the best time just now?
Yeah, yeah, if you feel like you're supposed to. Right,
All
because
right.
like I will say like what the way it happened with me, I didn't plan it at all and would have bet money I would never do anything like this. It just wasn't my thing. I was like a go to the party, but pull my hood up and like go in the corner and talk to like someone or whatever. You know, like I would, dude, I said no like 5 times to Bob when he told me I needed to start making videos. And here I am somehow. So I would say, yeah. And another thing I would say is people I hear people's like experience on the other end of the screen and they're like they say all these things and I appreciate the kind words and stuff, but it's funny because my boys in here, they know what really goes on. It's like I'll be doing a million things and then I'll like pop in Discord 20 minutes before the debate and I'm like, dang bro, I think I'm supposed to have an intro presentation, or I'm like, dang bro, I have a show tonight in 10 minutes or whatever, or in 30 minutes or an hour. And it's because like the creator's real, bro. The creator's gonna take care of it. And so I go into these debates, and literally the people in this room have seen it happen 100 times. I go into the room and I'm like freaking out. I'm like, I don't want to underestimate this guy, and what's he gonna say about this and this? And I'm trying to make sure I don't forget certain things. And then I do the debate, and I'm always reminded it has nothing to do, nothing that I planned, none of that matters at all. It's like totally irrelevant. So people
Seen it
should
many
know that.
times for sure.
Yeah, my wife sees it like all to the fullest extent. It's like with this whole thing. It's the whole reason we started this space. It's like the the podcast is in like 10 days, and we have to have someone like right now, and we still technically don't. But there's actually a part of me that's not tripping about it at all. Like I know whoever's supposed to be there is going to be there. However it's supposed to happen is going to happen, and I'm not tripping. So it's just a very liberating uh, thing that everyone in this room has access to. And then it's funny because I'll say one more thing. When you start to get into some of these things we talk about in terms of physics and ether and cosmology, we're actually starting to get a glimpse into the actual physical mechanisms that are used spiritually, right? Like there's a literal medium connecting you. Like there's a conduit, literally, right, where you can receive information, send information. Your brain's basically like an antenna, which has been proven. There's like a very real, like there's a reality to this that people I think don't realize. And so just check it out, bro. Check it out. Don't check it out, but you should check it out. Um, and that is all I will say.
Check
Yeah.
out the Ether Cosmology channel because when Whitsitt started talking about the ether and a lot of the drama happened with people trying to take ether off the table and all that, and say it wasn't even something we should even discuss. When you have to have the context of Michael Zamorlia and everything else to even understand the whole globe Earth versus flat Earth discussion. Anyway, that a lot of people really resonated with what you were bringing forth with the ether and the Ether Cosmology channel wouldn't be in existence without you doing that, and as well as a lot of our understanding of the world and a lot of things that have been so exciting about the discussion as of late.
I mean, dude, it's literally the only reason that I make content is because I found out about Flat Earth in 2016 or whatever, early 2016. So I was a flat earther for many years. And like I just would tell people in my personal lives, whatever. I didn't even invest tons of time. Like I put it together very quickly. Like for sure, they lied about the earth, right? Like I put it together very quickly. And so then I just defaulted to I'm just going to accept my experience. And I don't need some like full model or whatever. I don't even think that we may not even be able to know that. So I just went on about my life. But then, dude, I came across Theoria Apophysis in Willer, which is why I actually know I like for sure at one point we're gonna have a stream similar to how I had one with Owen because it's just like supposed to happen. And dude, when I heard him start talking, all of a sudden, all this stuff made sense to me, and I actually got excited and wanted to know. So flat Earth itself wasn't really that for me at first. It was like very eye-opening and, like, kind of life-changing in the way that you view the world. It's like it's it's kind of like when they tell you that how they know how everything works and what it is, you become very desensitized to it. You don't really appreciate it when you start it's like you're a child again. You realize this place is, like, incredible, and we have no idea really what it is, and it's just beyond our understanding. That's cool. That's really all it was for me. I wasn't in a pursuit to find a real map or anything. But dude, ether, bro, magnetism, electricity, dielectricity or electrostatics, that was it for me, bro. When I found out about how they removed the ether and all the implications, I became like obsessed. And then that's what made me start like talking to people on Facebook, and then they would all make fun of me. And I'd be like, okay, I get off work at 3. We're going to debate 4v1. I do live streams and I start ranting. And I'd be like, centrifugal divergence, centripetal convergence, the conjugate geometric expression, and everything's about pressure mediation. And actually, it's just a dibride of electricity, blah, blah. And Bob heard that, contacted me. I said, I'm good, but thanks. And then he talked me in to jumping on that show and then being a panel member. Um, So the ether is like that's why the idea that they were gonna try to tell me I couldn't talk about it is so laughably irrelevant. It's literally the only reason that I started ever making content, you know? So,
Well, I've paid
yeah.
attention to your story probably closer than a lot of people have, and I've got tons of stuff of you talking on my channel, and just to save it because it is epic, and it is definitely going to be something that is going to go down in history as what really opened a lot of people's eyes. I actually just posted one from you back in the day, that epic rant that someone put some music to, and I recorded it and I had it unlisted on my channel. So I just posted it back when you had the chipped tooth and the scraggly beard, but it's such an epic rant. People got to check that out.
Oh, when I have like the crazy beard, like my beard is
Yeah,
like
yep.
really, yeah,
It's in the
yeah,
blue pill.
yeah.
It's in the purple pill right now.
Yeah,
Um,
I remember. It was a Facebook Live,
yep.
and
It's
yeah.
great though. Still, it's a perfect thing for new people to look at, and you just sum it up so well, just as you always do. And yeah, and the ether has just made it such a more exciting conversation ever since that's been pushed to the forefront.
Yeah, and I'll say this one thing. So like the way I view this, I view it like, dude, I'm already over 30 years old. If I could go back in time and be like 15 again, like would I maybe like really try to devote my life to fast tracking, figuring this stuff out and formulating models and theories and stuff like that? Like maybe, I don't know. Because when I was 15, 16, I just cared about girls and football, realistically. But uh my objective now is not to like be some guy that figures everything out. I don't think that's what my role is. I literally just want to break through this paradigm we live in that's so it's like Orwell, it's like Orwellian, it's like gray. Everyone just lives in this gray world, and I want to just do my part in like breaking through that paradigm where we point out that it's obviously everything's electric, everything's magnetic, there's an ether. That's the actual answer to understanding what's above us, what's around us, how everything works. And it's really the next generation that's gonna figure it out, right? Like start to actually formulate something new. And so that's like we should all really think about that. What we're doing potentially is immensely important, and we just kind of have to, we have to fight the tougher fight for them, and then you're gonna have the next little Nikola Tesla pop up and be like, yeah, of course, well, duh, of course you get what's falsely being called gravitational lensing because there's plasma within a superfluid medium and everything's, electromagnetic. And so I think we're gonna see something a pretty major shift
Oh
in the next
yeah,
few years.
you've definitely done your part as well as a lot of us. Just normalizing the conversation, and I'd say we've already won because it is something that everyone's at least heard about by now, and the people that were laughing at us to begin with are now just running away from us because they'd rather not talk about it. And we've all seen it happen, and it's just going further into that area where the Overton window is, about to shatter, and you're
Well,
going to have PhDs lining up to talk to you.
what's gonna happen, bro, is history will reflect that this period of time was one of the most retarded periods of time in humanity, right? Like this time where people thought that atheism was viable, believed in things like evolution and abiogenesis, and that the Earth was 4.5 billion years old, and that there's an ever expanding universe of nothingness with magical force called dark energy and invisible matter that acts just like matter that fills up most of what's around us, but you can't find it or know what it is. And that time slows down and physically stretches out. Like these crazy, like it's gonna in the future, people are gonna look back at this time as like caveman level stupid. That's what I genuinely
Just
think.
laughing at it like we're laughing at it now.
Yeah, like I think that's gonna be for sure what happens. And so when like it's so obvious that the answer is everything has a fractal geometry, a torus field. It's all about torus fields, and double torus fields. And it's everything's about pressure mediation and everything's electric, and that it's right in front of everyone's face and very obvious that it's all about magnetism. and magnetism is the key, and just in like a handful of years, people are going to be like, how the hell did people like not know that? So, I mean,
Torus
that's what I
fields all the way down.
yeah, it's all like gonna be whenever people really start to piece together, the final product is gonna be very common sense and simple and just makes it's just gonna make sense because nature is simple, not simplex, to quote Ken Willer. So it has like nuances and stuff, but it's simple and it just makes sense. And so the current paradigm can't be, it can't possibly be true, right?
The powers that be have spent so much time making it seem like there is no creator, but once you start learning more about science and the way things work, you understand that there's no way there couldn't be a creator, and it's actually like really awesome, and it really like just pulls you right in. It's like a really cool book or something, you know.
Yeah, yeah, there's the famous quote, the first sip of natural sciences will have you an atheist, but at the bottom of the glass, God is waiting for you. That's basically how it works.
Totally
All right.
agree with that.
Alan, I don't know if you're still wanting to do this. Thank you for being patient. I don't know if you guys are still wanting to chop it up or not, but
Yep. I'm just chilling.
Yeah, ready for it.
Ready whenever
Yeah.
you are, sir.
Gosh, I might have to leave and come back. Sorry, my audio is glitching out hard. One sec, I'll be right back. I'm sorry.
all right, we'll bring you back
Yep.
up.
I'm gonna
Anyone have like
restart as
any?
well.
Okay, cool. Anyone have any final things they want to say really quickly, and then I'll just kind of lay out the general premise of how we're going to let them go at it.
Hey, shout out to Isa Mahalski real quick, but I'm sure you got that.
Late, so I am willing to help you. I sent this AI list with possible debate partners. So if you can't reach everyone or something, I don't know if you talked about that, but I can write more people if you like to. But maybe you talked about that already.
No, I appreciate it. I went through your list. I sent lots of emails.
Cool.
Yeah, like obviously, if you want to reach out to people, I could send you the people I reached out to,
Yeah,
and
that.
I have an email typed up I'm sending to people. The only issue is like some of those people are not from the US, and so
Yeah, yeah.
that's the only thing. Although most of them are, I can tell you actually told it to be from the US. But other than that, yeah, like basically what's happening is everyone's just saying no. And what can you do? You know, people are like, clearly it says flat Earth in the email, and I'm not gonna lie to someone and get them to come there and not like thinking it's just geocentrism. It's not. It's gonna be flat Earth. So whatever. I do
Anyways, we can
appreciate the
extend
list.
the list on and minimize it to US guys, but and where which you the state is important too, because flying in is yeah, I don't know if people like to fly in.
Yeah. So I'm not gonna say exactly where it is right
Yeah.
now because it'll give it away what it is, but um yeah, like we can message it's in the email as well. It's all travel expenses covered. They'll pick them up from the airport, all that.
Okay.
Um but yeah, it would obviously it's still a whole thing. Someone's gonna have to travel and blah blah blah. But it's very beneficial. If anyone has any aspirations to create content in any way or already that's why it's best that they already kind of have like a YouTube channel, X account, or whatever, because it's a huge opportunity for them in that sense. And most people would like jump at the opportunity to be on the show. And so it's just very interesting to watch these people turn it down because the topic, but whatever.
Yeah. Anyways, write me. I help you out to write more people.
Thank you, man. All right, is he? Oh, he's requested. Okay. Alan, are you back up here? He says resetting, but I'm not sure what that means. Anyone else up here got anything they want to throw in before we?
Shout out
I,
to Sacred, by the way. I think he got 10K on X, so I just want to say that real quick.
I just want to say real quick, to think that there's no creator. I forget which physicist said this, but he must have been a sensible one. He said that to think that this beautiful, complex world is without a creator is like saying that you can give a monkey a typewriter, and by sheer coincidence, it would type out an entire play of Shakespeare. So I thought that was pretty clever.
Yeah, you know what's so crazy is it's the extents that people 1 million years old and the bottom would have to be 10 million years old. That doesn't make any sense. Oh, well, there's just something we don't understand right now. There was no great flood. Oh, here's like an immense amount of geological evidence that definitively proves there absolutely was a massive flood. Oh, well, there were localized floods, but there couldn't have been a worldwide flood like every civilization ever claimed. And the universe is expanding and we're not in the center. Oh, but here's the evidence we clearly are in the center. Oh, well, it's accelerating and expanding. Oh, well, here's the physical test that shows it's not. Oh, well, time slowed down. It's like they will say the most retarded stuff to make sure there's not a creator. It's like
And it's so funny how
insane.
they said the world was covered in water, but then people say, oh, there's not enough water for the world flood to happen. But they said the early Earth was covered in water in a water world.
Yeah, have you guys ever heard of I'm pretty sure this is not actually what it's called, but it's something like the early faint sun paradox. Let me look up exactly what it's called. You guys ever heard of anything like that?
No, but Liliana was
Yeah, I
mentioning
have.
something really interesting about the sun too, by the way, just a bit ago.
It's called the faint young sun paradox. Starting talking about how there's a known rate that's roughly constant at which the sun, grows brighter and hotter with respect to time. And if you just reverse the equation and go backwards, it would be smaller and cooler. And if you go back to the time scale when they said that the Earth would have, formed and life would have started, it would have been like a frozen ice ball and wouldn't have supported life at all.
Yeah, exactly. Yep. Like within their model, back in the day, the sun's output would have been like 70% of its current output. And that would mean that the earth would have been like completely frozen and couldn't have supported life, obviously. But their model requires that there have been liquid water that supported life early on. So yeah, it's called the faint young sun paradox. Yeah. It's a trip. Like what people just dismiss it. Like if you call it paradox, somehow it's okay. Like, no, that means what you're saying can't be true, bro. So anyway, just throwing that out there. Pretty interesting.
The water paradox at the start of life. You need water, but then in water everything disperses. And like the oxygen paradox, where you need oxygen, but in the presence of it, everything would oxidized. There's so many paradoxes, it's unreal.
Anything but God. Anything but God. Oh, there's
Yeah,
an
man.
infinite amount of universes.
Infinite
Yeah, that
regression paradox.
before I ever found out about like the cosmology stuff, I was on the whole, evolution and the Big Bang stuff is fake and gay for like, you know, my entire adult life pretty much. And it was I learned about a lot of these things, and it's funny how many of them I learned within the paradigm of the like heliocentric model in order to still like explain it. I believed in like a 6,000-year-old heliocentric universe, which is funny now that I think about it, but it's like even there's so many other things that create problems um in their model, both biologically and physically. Uh, the appearance of like um, fully formed organisms in the fossil record, the fact that radioisotope dating doesn't work, Like there's just so much of it, bro. Like it goes on forever, and there's no answers to any of it. But yeah, I think the faint young son paradox is something I've never heard any type of refutation to.
No, that's why almost no one's ever even heard of it. It's like they just anything that they can't really address, they've just completely hidden. Same thing with Aries failure. They came up with a cover story for Michelson Morley the best they could because they had to revise the entire model and all of physics just to try to keep it alive. But so they kind of have to tell you about it to some extent, but they just like omit the Aries failure thing, bro. It's same thing. It's like if you can't address it, just hide it. Where did Alan go?
Where did that dude MV go? Anyway.
While we're waiting for them to come back, I did kind of mention in between there when you were talking about the sun. I don't know if Liliana wants to reiterate what she was saying to us about the sun actually rising in the west and setting in the east, according to some of the lore that she was looking into, which is another interesting idea, speculation, of course. But I
Well,
don't know.
it was Solon. Is that how you say it? Who told Plato in Egypt that at one time the Atlanteans, because he was telling him about Atlantis, and then he told Solon. Solon told Plato that according to the Atlanteans, the survivors, the sun actually used to rise in the west and set in the east. So it was a different cycle. But regardless of cycles or what the age of the earth is or any of that, the point is there is a creator, period. Because I think another analogy that same physicist gave, and I'm embarrassed to say I forgot his name because he sounds like a physicist. We should know his name because he sounded sensible. Because somebody asked him, "Do you believe that there's a creator?" And he said, "Yeah." He said, "If there was no creator, that's like saying that you have all these spare parts of an airplane sitting in an outdoor warehouse, and then this wind comes through." And it's just the right the right velocity and the right kind of strength, and it whirls around in just the right ways that it takes all these spare parts and puts them together to make a plane that can actually fly. And then he's the same one that said, it's as absurd as thinking you could give a monkey a typewriter and by sheer coincidence it'll type up an entire play written by Shakespeare. So yeah, you need a creator. There's way too much intelligence and beauty and symmetry and just all the laws of physics that have been put in place. And none of it makes sense if there was no creator. And I think even with the theory of evolution, I think even it was Charles Darwin himself that said that nothing would have propelled evolution to create eyes or ears so he himself admitted that his theory had plenty of holes in it.
Oh, sorry to interrupt, but Alan said he requested a speaker. I'm not sure what happened with the shuffling there. But...
Hola, senors.
What's up? Sorry, I was like, where is this man at?
Oh, you're good. You're good.
They had you frozen on, I guess, like co-host still. So.
Yeah, that's my fault. I should have had you remove it before I left.
All right. Well, you guys have been patient and take it away. I think you guys will be able to cordially go back and forth yourself. People try to not just jump in and interrupt or anything, please. If you really feel like you need to say something, you raise your hand and we'll see what happens. But cool. I think that's really all. Anything else we need to cover before you guys start talking?
Yeah, should be fine. Unless you have anything to say, Mord.
No, I think I'm good from my side. Let's just focus on
All right, cool. Well, before we begin, I want to say thanks, Mord. I appreciate you taking the time to have this conversation. I've been trying to have it with as many people as possible. And for some reason, they just stop, you know, they don't want to hang out anymore. So I appreciate you coming through and having the convo.
Yeah, no worries, man.
Cool. All right. So as we get into it, before we talk experimental results and interpretation, I think we should both lay out what we think or how we're going to interpret it, rather, right? So I was going to go over special relativity. And as we go over that and see, like, you know, where you agree, where you disagree with the framework of interpretation, we would go from there. And then, of course, I would lay out my position for my interpretation as we go through those as well. Sound good?
Yeah, sounds good to me.
Awesome. All right, so let's start with Einstein's 1905 paper on the electrodynamics of moving bodies, where he lays out his first two postulates. So this will be very important for how we interpret experimental results for falsification and adherence. So the first postulate is that all inertial frames are equally valid, and he defines an inertial frame as in uniform rectilinear motion. So in other words, you're just traveling in a straight line at a constant velocity. Do you agree with that interpretation?
Yes, I think so.
All right, cool. Solid. So second posti, that the speed of light in a vacuum is independent of the source that's emitting the light or the observer that's receiving the light. And basically what he's saying there is that the velocity between the two can't be measured by the difference in the speed of light.
Yeah, we would call that the isotropy of the speed of light, right?
Sure.
Absolutely, yeah.
Awesome. Cool. So third part down here at the bottom on the first page, he says that we won't need to introduce a luminiferous ether. So he doesn't require any physical medium. Earlier, you and Austin were talking about Poincaré and Einstein's theory and the mathematical equivalence between length contraction and time dilation versus a physical mechanism proposed by a static ether that would cause the molecular contraction, you know, supposed molecular contraction and whatnot to facilitate that interaction. And here Einstein's saying, you know, no medium. So just space is empty. And then he goes on to say a very important piece that super pivotal here. So he says, we will not use absolutely stationary space or assign it with special properties, nor assign velocity vectors to a point in empty space where electromagnetic processes took place. So in other words, all motion will be arbitrary, or like, you know, inertial reference frames will be arbitrarily defined between two observers in motion. And there won't be any fictitious frames or any references to absolute space because all motion and velocity is relative.
Yeah.
Cool. So let's see, what one was that? Was no imaginary vectors. All right, cool. And then of course, we'll go over relativity of simultaneity briefly, but due to the consequences of the constancy of C in inertial reference frames and all inertial reference frames being defined as being a uniform rectilinear motion, there will be sometimes simultaneous events that occur will not be simultaneous in the opposite frame, and we could just kind of leave it at that for now.
Yeah, I think that makes sense.
All right, cool. RS standard definition. Cool. All right, so the next part where it gets a little tricky, we might have some contentions here, but in I'm not sure what page it says, but this is section 4, the physical meaning of the equations obtained with respect to a moving rigid body and moving clocks. And he says here that suppose he's laying out a thought experiment where he says, essentially think of an atomic clock, because they didn't have light clocks back then, but this is what he was actually describing, was two atomic clocks that are synchronized. And you move the one clock around the equator, it completes a circuit. And when it comes back, it will be out of sync by 1/2 times the time it took to do that loop times the velocity squared over c squared. So he's introducing how much it'll be desynchronized, and he's defining that his equations apply in a uniformly rotating frame as long as it's a closed polygonal loop or a continuously curved line. So in other words, a circle.
Okay, one sec. Sorry, I was just opening some shit as well.
If you need a screenshot, I got you. I can send it to you.
Yeah,
on
I think that would be
Telegram.
helpful for that one.
Yep. Actually, let me call you on Discord. I'll screen share, and we'll just mute in the call.
Perfect.
We'll continue talking
That's a
on
perfect
here.
idea. Yeah,
Yep.
excellent idea.
Gotcha.
That'll make things a lot easier.
All right, 1 second. Uno momento. All right, we should be good.
If you want to share those in the purple pill too, if possible at all, that'd be great for anyone listening.
Yeah, so here's what I'll do, Dave. As I'm going through it, I'm going to send you the screenshots, and then you can post them on the purple pill for everyone. How's that?
No problem. No problem.
Awesome. My man. So here we go. Here's what we're looking at right now. If you can go ahead and throw that up. So, yeah, if you want to take a look at that, Mord.
Yeah. That's all good. Yeah, it was just a little difficult to parse all that without reading it, but yeah.
Yep, you're good.
It's only Einstein, though, you know. So
yeah, you're good. So uniformly rotating frame, his equations hold true, and he's giving the function of time dilation for the desynchronization based on the function of the velocity squared with respect to the stationary clock, right?
Yep.
All right, very cool. All right, let me see where we're at here on the checklist. Let's see. We got simultaneity, we got all that. So, okay, so Lorentz symmetry, this is very important. So link contraction and time dilation are part of Lorentz symmetry, right? And that facilitates covariance. So the changing of the time axis and the x-axis is what you would need to do a successful Lorentz transformation. Would you agree with that?
Say that one more time.
To facilitate symmetry in space-time, you have to change both the time axis and the length axis. And
yeah. So you're basically saying that from one point of view, there's length contraction, and from the other, there's time dilation?
No, they would both be in the same frame, and then you could transform to the other frame and put them on the other frame.
Oh, okay. Yeah, I see what you're saying. Yep, that's good.
Cool. Okay, so a valid use of Lorentz symmetry is, fully adhering to that space-time symmetry where it's the space and the time that change together. That's why they're not hyphenated. And this is just clarification for everyone, not just like yeah. So anyway, okay, cool. So we agreed on the mathematical framework, the postulates, the consequences. I think we can go ahead and start interpreting, but let me lay out my position first, since I kind of forgot to do that as we were going through the relativistic framework. So my framework is that an inertial frame is defined as stationary, and I would define the Earth as an absolutely stationary frame. And when we get into the experimental analysis, all references where we do it where we analyze the measurements with respect to a stationary Earth, the correct prediction will be made. I predict that the speed of light will be measured as c plus or minus v with respect to the velocity of the observer, where v is that velocity. Let's see. A form in uniform rectilinear motion is defined as an inertial frame. In some cases, I agree to that. But in dynamic analysis, it can be shown that only a stationary, non-rotating frame actually makes the correct prediction. And let's see. Time and space are absolute. So as a consequence of that, the relativity of simultaneity, which states that different physical outcomes would lead to different physical, that different the simultaneous events occurring in a reference frame that's moving will appear differently, and that's not just an apparent effect. It has physical consequences. Whereas in the ether theory, where the Earth is stationary, time and space are absolute. So relative simultaneity would just be an apparent effect in this theory and not a real one. All simultaneous events would lead to the same physical outcome, regardless of velocity. All right. And then any measurements made that would be attributed to the earth, to the motion of the earth, I will attribute to the motion of the stars, translated down through an ether mechanic that follows sidereal time. And then if you have any questions, let me know.
Yeah, on that point, so are you kind of following the Alpha Hildegard model here in terms of there being like an ether wind? Or is the ether a Lorentz rigid ether that is like a fixed absolute frame of reference?
No, it is a dynamic ether, and the earth is the absolute lab frame.
Got it. So basically alpha then, right?
Yes.
Okay.
All right, cool. So do you want to start off with, let's see, where would you like to start, sir? Now that we've agreed upon terms and conditions.
I guess I would posit a couple things. So let me share my screen here. I have put together also a little thing here, but I don't know how easy it will be for me to share these to the Jumbotron here, but give me 1 second. Let me share this. Okay. So I'll essentially posit a few things that I think are basically going to lead to contradictory outcomes as it pertains to some of the definitions that we had that had been put together. The number one, in terms of, so I accept the interpretation as presented of the basis of special relativity, but the issue now will be positing how that relates to geocentrism, Mach's principle, and the translation of motions onto the Earth. If we apply the standard of absolute space, a stationary Earth necessitates an absolute space that is centered on Earth. There must be, it has to be stationary with respect to itself, providing an absolute frame of reference, the lab frame, as it were. In terms of going off of that now, we start to run into dynamical problems with any sort of geocentric system that is posed relationally on top of that. The reason being that relational mechanics relative to a rotating universe around the Earth, even if it were to apply to the case of a spherical Earth, let's say, will create an issue where we are not able to reconcile the need for an absolute frame of reference with relative accelerations and motions. And in particular, so there's a couple key points here. So the first one is that when we talk about the action of what you would call perhaps fictitious forces, or things that are producing, for example, precession on the force of the Earth, that are in my framework explained by the rotation of the Earth causing those forces. They cannot be replicated by a relative acceleration relative to the absolute frame of the Earth. Basically, you're going to run into several problems here. The first one being that you have a sort of symmetry problem. So you would have basically, in the case of Newton's bucket, let's say, for example, so if we have the rotation of the bucket, and we're making an assumption that there's the action of Mach's principle and an absolute frame is defining what we see as for the sake of the bucket. The action is universal despite separation, and that is not in accordance with the idea of a relative universe that's moving around the Earth. And indeed, the entire notion of a universe that is spinning around the Earth, however that is portrayed, and causing the dynamics on the Earth itself, is itself going to be in contradiction, because we are not going to be able to replicate the effects of what is observed without accounting for the fact that in one frame of in one case the the accelerations ought to be relative, but they necessitate an absolute frame at the same time. And that is going to be a fundamental contradiction in a geocentric position that is so proposed. When it comes to the notion of the Earth communicating down to the surface of the Earth with regards to describing, for example, precession of gyroscopes and things of that nature, rather than it being a motion of the Earth. If we do not assume that there is a rotation of the reference frame causing those effects, as would be observed. So basically what I'm positing is a unified effect, the Sagnac effect, which is described by the rotation of an interferometer, is precisely replicated when we have a measuring device such as a ring laser gyroscope. Such an effect is observed as a function of rotation in the lab, and it is precisely observed in the same manner when it comes to the Earth. I would like to see any sort of dynamic equivalence that can thus be proposed to explain this in the opposite situation that does not run into the issue between the contradiction between accelerations being relative in one frame and then needing an absolute frame at the same time. The other issue that basically I have is that there might be a case of a ether wind that is producing a observed sort of Sagnac effect in interferometers. I do not see how such an effect manifests in precisely the same manner in mechanical devices. And again, we can replicate that the fringe shift occurs in the Sagnac effect as a consequence of special relativity and the postulates that we had mentioned, and does not occur due to any sort of communicative effect of the ether. If it were the case that it would, it does not make sense that the precisely equal effect is observed as a precessional effect in mechanical gyroscopes, both of which can be replicated in the lab and then measured on the actual Earth itself. So I think that's kind of the fundamental point. And then when it comes to the work of, I think everything else is firmly consistent with relativity with respect to the history of interferometry. The only result that Einstein himself posited would not be the case and would sort of falsify relativity, as it were the results of Dayton-Miller, which we're all familiar with. I posit that the results of Dayton-Miller are explained precisely in the same way by the same effect, which is the actual rotation of the Earth, which is basically the fundamental point of my argument, is that the effects of the rotation of the frame of reference of the Earth cannot be replicated by any rotation around the Earth as an absolute frame. And in particular, what I'll present here is the paper describing the quadratic Sagnac effect. This does get a bit more technical, but essentially what it says is that when we have a Michelson type interferometer, and especially the type of Dayton with extremely long arms, taking a very significant light path, the Michelson interferometer arms will have a differential orientation in the rotational plane. When we apply a rotational force or a rotation to that frame, we will then have a differential effect of Coriolis on the different arms of the interferometer. And this paper derives precisely that the experimental data can be explained perfectly within that framework, and therefore there is no measurement affirmatively of an ether wind. Rather, all of these effects are explained best by the rotation of the Earth itself.
Nice. All right. So to start from the beginning of that a little bit, you were saying that there's dynamic problems, et cetera, et cetera. Well, this actually comes from following Mach's philosophy that the Earth is a rest frame and also the absolute stars. Well, he was half right. All the problems you mentioned go away when you make everything with respect to the Earth and you take away the secondary fictitious frame. Can you mute for a second? Your mic's coming through.
Oh, I'm sorry.
You're good. So those issues are alleviated, and actually Andre couldn't answer anything about Newton's bucket in relation to what you raised as well. The only frame that makes the correct prediction for dynamic forces is the lab frame. and which is the Earth, the only place that these experiments are conducted. So, only acknowledging Mach as half right, I would say none of those issues, I skirt by those, but you should definitely hit up Andre Assis and see what his refutations to those are, because he doesn't have any, because he wants to have the absolute stars and eat his cake too, or whatever they say. Now, when we get into absolute space, that doesn't have to be with respect to the center of a rotating globe, which will be invoked as a fictitious frame for relativity theory. But before we get to that, the idea that mechanical precession, especially things that have a periodicity to them, like rotation of gyroscopes and pendulums, can be specifically attributed to having a retardation relative to the ether wind relative to their latitude, and then their orientation being preserved with respect to absolute space. That doesn't have to be at the center of a globe, right? So that's that wouldn't be a valid, that's like forcing a one-sided interpretation of the coordinate system where it could be applied anywhere. And then when you get into anywhere on Earth, and when we get into the proof that the Earth is rotating, especially in regarding interferometry specifically, and in GPS, what you'll note is that there is no north-south variance in the speed of light, which is highly critical in proving that you are on a rotating body. And even if you were, even though the north-south variance is going to be different than, or much less than the east-west variance because of path length and then actual rotation, right, of that body. If you're on a rotating sphere, the north-south variance is going to be much less than anything going with the direction of motion, right? So, but even with that said, interferometry is so precise, you can measure down to 10 times 10 to the minus 10 wavelengths. There's Armstrong wavelengths of neutrons measuring the Sagnac effect, which is, they say Earth rotation. But when you get down to those wavelengths and that accuracy of measurement, even on that scale, there's no north-south displacement. It's only in the east-west, which would be, which is what the ether wind model predicts with, so a stationary Earth with respect to an east-west ether wind bias. So that, so having no north-south variance in the speed of light for GPS over great distances where the time of flight is going to be much greater than what you would get out of any interferometer is pretty damning, showing that it only shows or happens in east-west. Lends more credence to the alpha theory, and then to talk about Miller's differential time dilation explanation, right? When we get into the quadratic paper, you'll note that guy Millikan doesn't do a symmetrical transformation. He uses absolute space to preserve a center point to have there be a timing difference to produce the first order fringe pattern that's measured, right? This isn't a time dilation second order effect. So relativity, like dimensionally, doesn't even have any explanatory power because it would predict a much smaller fringe anyway. But in addition to that reciprocity of, in addition to that violation of Lorentz symmetry, being the asymmetrical use of the mathematics, only using timing while preserving absolute space to have the difference, there's no north-south variance. The arms that were in the north-south direction don't experience any variance. So how could you attribute that to Coriolis force when that's, you said that that's a real force based on a rotating ball? Well, if that's a real force based on a rotating ball, that's going to be a deflection from the, traveling north-south tangential to that rotation in the east-west direction. And the interferometers in the arms that are east-west are the only arms that get a fringe reading. So I will scoop up all of those as ether wind. And if you use the Coriolis equation, right, when you go through it, the mass in that equation also cancels out, which it just comes out to be an acceleration. And if it's just an acceleration in a preferred direction to give C plus or minus V, where the plus is going with the direction, then that acceleration that indiscriminate acceleration just becomes ether wind.
Okay. Yeah, I get what you're saying. So the first thing I think I would like to clarify in response to that, so there's a couple things here. The biggest thing though is this notion of being able to replicate the dynamics of the Earth with the motion of the stars, communicating, as it were, through the ether. I don't see how this squares with a ether wind exactly. Can you explain that to me? Like, how does the ether wind propagate? Is it
Yeah,
across the
yeah.
Earth? Is it vortexes? Like, what is the model of ether wind?
Yeah. So it's a vortex that emanates out from the North Pole over on a flat Earth model, right? On a globe, it would be doing, some sort of vortexual motion emanating out from a North Pole too, as well, I would assume, and then just doing its normal rotation stuff. But anyway, the motion of the stars, that's all that's measured with interferometry. So all the interferometric measurements that you were talking about, they plot the minimum and maximum dimensions for the speed of light throughout the day. And when they plot that against sidereal time and do a Fourier analysis on it, excuse me 1 second, it makes a sine wave. And that shows them, a strong correlation that what they measured was some sort of rotation that corresponds to the sky. Now, obviously, if your framework of interpretation is that the ground beneath you is rotating, you'll think that you produced that measurement. And if you think the Earth is stationary, then you'll think that there's a translation of motion that comes down from the sky. Now, however you want to interpret that part of it is really kind of philosophical, right? Now, when I say like it's translating it from the sky, what I'm saying by that is that the minimum and maximum dimensions that are measured throughout the day that show that fluctuation, that the causal mechanism of that is that is due to an ether wind that is matching that rotation.
Interesting. Okay, so I'm curious here though. So you have a model then of ether wind that follows a vortex, a sort of vortex lines, as it were, and then presumably that's how you try to account for latitude-specific effects, that there would be sort of differential flow or something like that.
Yep.
But
Does
it emanate from a single point, or?
Yep. As you get further away from the North Pole, the speed will increase, which will give you the latitude-dependent effects.
So we have on your side, you claim Dayton Miller's measurements. You claim that would be positive evidence of ether wind rather than the Clayton-Sagnac effect that I put forward. Can you posit a derivation of how the ether wind would vary with altitude with Dayton Miller, and in regards to your specific ether wind?
Yeah, I do have a equation for you. I can give me 1 second. But in regards to the mutual exclusivity, I wanted to also talk about that real quick in regards to the interferometer readings, because can you mute for a second? Your mic's doing a little static.
Oh, yeah, sorry.
So in regards to the interferometer readings, and especially the Sagnac effect in particular, relativity theory, as we went over earlier for a rotating frame, predicts that both of those, that the observer and the rotating source are in inertial frames. Therefore, the speed of light should be measured as a constant, and there should be no fringe pattern. So if while I'm getting my latitude or altitude dependent velocity gradient equation, are you able to produce a derivation of the Sagnac effect that's derived under the principles of relativity without invoking a fictitious frame?
What do you mean by fictitious frame?
So when you go through the Sagnac explanations and relativistic papers, what you'll notice is that they do a cylindrical coordinate system transformation where they'll align with the axis of rotation in the fictitious frame, and they'll move the observer to that center frame, and that observer will then watch an observer on the rim of the device, not measuring the speed of light as a constant. So they're preserving that position at the center to basically account for the distance change so that they can have the timing difference to predict the full fringe shift pattern. So without the fictitious frame at the center, using the cylindrical coordinate system, they have no ability to account for the first order timing difference.
You keep mentioning first and second order effects. Why is that relevant here, and how do you define this?
Yeah, so a first order effect would be when something is directly proportional. So for the examples that we're talking about with interferometry, this would be like the fringe shift reading is directly proportional to the velocity that's being measured, whereas a second order effect would be a smaller effect, and especially when you get into the mathematics. Specifically with relativity theory, it's a second order effect in that it's a result of a velocity and it's a function of velocity squared over c squared. So it's actually, if relativity predicted a fringe, it would be a much, much smaller fringe than what's measured in the first order from the Sagnac effect, as it's directly measuring velocity.
Let's see, so I have a derivation here. So do you see my screen? JB Malikan, Sagnac effect, correct and incorrect explanation. So it does go through listing Sagnac effect in the special theory of relativity, and then
I don't see your screen, but I'm familiar with that lad's paper. And what you'll notice is that he does the Lorentz symmetry violation as well. And he doesn't do link contraction and uses absolute space to preserve a preferred frame so that he can have the first order timing difference. So if you actually...
In what sense is the frame preferred, though?
What's that?
In what sense is the frame preferred, and how, like, can you differentiate between, so you mentioned absolute space and a preferred frame. In what sense are those invoked here?
Yes. So without invoking that cylindrical coordinate system transformation, relativity theory has no ability to even attempt to explain the timing difference. Because what you need is you need to have the distance is changing, right? Because it's rotating, but you're not assigning imaginary velocity vectors where electromagnetic processes once took place. You have to, so what's going to happen if the speed of light is constant for these two observers, the source and the actual photographic recorder that's recording the fringe pattern, those are our two observers in the uniformly rotating frame. What's going to happen if there's a distance change and the speed of light is constant between them? There's not going to be a timing change. The speed of light's going to complete the circuit at the same time, and there will be no fringe shift pattern. But what's actually measured is a timing difference that's directly proportional clockwise and counterclockwise with respect to c plus or minus v on that, with respect to the orientation of that clockwise or counterclockwise motion.
So I have the fringe shift derived here in terms of, let's see, we have omega, capital omega, c, and r squared. It's not clear to me how this creates a preferred frame.
Where are you screen sharing?
Oh, sorry, I was, but then didn't look like it was coming through, so let me start again.
Okay, let me stop mine.
Oh, I was probably just sharing my notes stuff. Okay.
Oops, there we
go.
go.
Yeah, let's look here. So I guess your issue would be this frame of reference K prime.
No. So let's see here. Where are we at? So to have this timing difference, it inherently requires a preferred frame because otherwise the measurement's just with respect to V over C, essentially. So if you're just using the timing difference and not changing distance, you're using that preferred frame with that equation anyway. That's the issue with his violation of Lorentz symmetry. That's why there's no complete answer to the Sagnac effect in the relativistic framework, because of this exact issue that you can't satisfy actual Lorentz symmetry.
Well, hold on though, because you keep using the word preferred frame, and I'm not seeing how this is, so preferred, and so I guess there's kind of two pieces here. So a preferred frame would be one in which what happens exactly in your view?
Yep. Okay. So if you look at the equation here, we got delta t prime equals delta t squared over 1 minus r squared over omega squared, right? Over c squared. Now, when we have r squared and omega squared, I'm guessing those are going to be the velocity components here and the radius that light has to travel on its circuit. And then see how it's over c squared?
Uh-huh.
Okay. That's relative to light's frame. That's, in other words, that's in that equation, right? In that classical derivation there, that's invoking a preferred frame just from that.
So, but you still haven't defined a preferred frame though. What is a preferred frame?
Well, it can be any stationary coordinate system that's defined, So in regards to dynamic predictions, right, that would be the Earth frame. And then when you're getting into fictitious frames and coordinate systems where you're introducing a fictitious observer and all that, that's just absolute space. So it's just conceptual. So like the coordinate system specifically isn't defined here, but when it's just left over C like that, that is the classical interpretation that it's with respect to light's inertial frame, where light would be propagating at that speed. That's what the interpretation of the equation is. And what you'll notice here, what you'll notice here, though, more importantly, is that this lad doesn't do any link contraction to satisfy this timing offset here. Because if he did that, the speed of light would complete its circuit in the same time without that preferred frame. So I'm not sure what we can
so
do
you're
much
saying
more here.
that there should be you're making a distinction now between an inertial frame in which light is moving and a preferred frame in which we're viewing this from. I don't quite get your criticism here.
Yeah, the equation describes a timing difference in the speed of light with respect to absolute space. That's how the measurement is made. That's what that equation means.
So the entire principle of relativity is that we don't derive things from the perspective of absolute space. So I'm curious as to the existence of. I'm curious as to the existence of absolute space as it pertains to this derivation particularly.
Yeah, well, like I said, in this particular derivation, it's just the mathematical conception as defined as over C. So it's that velocity part of the equation, right? Over with respect to what, right? Well, with respect to C and its inertial frame. So that's how they would look at it. That's how they're deriving the timing difference for the clockwise and counterclockwise rotations, and then that's what they measure.
So all I'm seeing here in terms of the actual paper derivation, the claim here is that we have two sets of coordinates, right? We have the laboratory set of coordinates relative to the actual rotation. And then we have the K prime frame of reference that rotates with the interferometer. So are you alleging that K prime is a preferred frame, and what would the absolute frame be?
Well, this is them trying to set up like a relativistic analysis of it. So they're introducing the lab frame there as a stationary system for it to be relative to. So that is obviously always going to be a lab frame. That's always stationary. That's always non-moving. Now that's always absolute. Now, when you get into the equation though, specifically of what he's showing with delta T prime, like right when you get into the actual fringe shift prediction measurement, it's the area light has to travel. So your R squared times omega squared over C squared. And that C squared there, that is invoking a absolute coordinate system for that motion to be relative to. That is a fixed point of reference in that equation for there to be, for that top part to be relative to. Yeah. Does that make sense?
I'm not sure that that's how this works, but let me make sure that I'm representing things correctly and your point. So, so we have a co-moving frame of reference K prime, right? And you're saying that we need a frame for this to be relative to. Why would that be the case in relativity?
Because otherwise you don't make the correct prediction. If you don't have a point in absolute space to preserve, then you're not going to have the timing difference. The speed of light will complete the circuit at the same time, irrespective of the distance change as it rotates. So that's why this guy doesn't do an actual Lorentz transformation. He's using a classical derivation for it and presenting it as a first order time dilation or something. It's mathematically, it's not even a valid use of Lorentz symmetry, because like I said, if you don't have the link contraction component to it, then you're not satisfying Lorentz symmetry specifically, and you're just invoking absolute space to give a first order answer, which is explicitly against what we read from Einstein earlier at the beginning there. And then if you want, I could show you a derivation of what Sagnac predicts under or what the fringe prediction is for Sagnac under relativity theory when you define it under its principles and postulates.
Right, but I guess so. The fundamental issue here, and this would also pertain to the other would this pertain in your view, I guess, to all derivations of the Sagnac effect, whether they are higher order or not? Like we have the class, not the classical, but the sort of classic representation here as a rotating frame of reference. It also would apply similarly to the quadratic Sagnac that had been proposed, right? In your view?
Yep. Yeah. There's not a single derivation to this day that for relativity to derive the Sagnac effect. It's
and your claim
without violating its
there.
postulates.
Your claim hinges there on the notion that when we move to this reference K prime, we're really making reference to an absolute reference frame and therefore violating the postulates of relativity. Is that correct?
Yes, sir.
Okay. So let's maybe go to the counter derivation, and then we could come to perhaps where we're going to be between the two.
Okay. Let me see.
So show me what the can you derive the effect classically, or what is the claim with regards to?
Oh, absolutely.
So,
absolutely.
Yeah. So two things here, I guess. So the first one is we have Earth, the entire Earth being an absolutely stationary lab frame. Presumably, you're, for this purposes of this discussion, using a flat model of the Earth as well, or that is the asserted basis of the Earth for your derivation here. Or
well, none of these equations could tell us anything about the shape of the Earth, really. So, like the conversation here is pretty much, the correctness of relativity theory versus a dynamic ether. So, a stationary Earth or one in motion, regardless of what coordinate system you prefer to view it under. For the purposes of the conversation, there's no point in convoluting it.
Well, I mean, it does kind of matter, though, with regards to our ability to derive a consistent explanation for the Sagnac effect,
well,
and
hold on.
how it relates specifically to what is attributed in one frame of reference. So there would essentially be, like, let me just clarify this so I make sure I have everything sketched out correctly. So there would be essentially three models to consider here, and the first model is a rotating Earth that is in what is, for the purposes of relativity, essentially a linear motion with respect to special relativity, right? And the claim would then be that the rotation induces an effect which creates, the Sagnac effect in laser interferometer, and as well as producing precession in physical pendulums and gyroscopes as well. The second model is a spherical Earth with a lab frame centered at the Earth and an aether wind that sort of has a vortex nature or moves relative to the Earth. And then the third model is a flat Earth model with the basically the aether moving over the stationary Earth as well. So I think those are the three models to consider here.
No, I see where the confusion is coming in. You said that on the globe Earth, the lab frame would be fixed at the center of the Earth. Incorrect. It would be anywhere on the Earth, anywhere on the surface, right? That's the lab frame. That's where experiments are conducted. They're not conducted in the center of anything in regards to a flat Earth or a globe Earth. So that's there's only two things really in discussion here, and it's motion, either due to the rotation of the Earth or due to a dynamic ether wind, and the latitude dependent effects due to an ether vortex on both models facilitate the same outcome. So for the sake of simplicity and not getting dragged through the weeds, I'd like to keep it to just the effects being measured.
Yeah, but the issue here though is that the ether as you present it is a physical medium, right?
Mm-hmm.
Or am I not understanding that right? What is the
Correct.
nature of the ether? Is it a
Physical medium?
Is a physical medium, and it
Mhm.
rotates. Therefore, presumably, it's not particulate in nature or something, but it has some sort of like fluid property, right?
It has electric permeativity and magnetic permeability properties.
Okay, and it affects the propagation of light. So you mentioned there's a c plus or minus v velocity.
Yep.
Is that with reference to the ether wind? How does the ether wind flow affect the speed of light?
Yes. As you get further away from the North Pole, you will have a speed increase following toroidal geometry. So as you get closer to the equator, the speed's going to get faster, and then it's going to come to a null point where you're not going to get a reading because the south is also part of the toroidal field, and it's meeting at the equator as well. That's where they intersect. So that's where you're going to have a null point. So all the predictions between the two models is like dude, we're trying real hard to talk relativity here. If you want to do like a flat Earth dissection of dynamic ether wind models, like we could do that another time. I really want to stay on point to relativity and motion and what the causal mechanism is. Trying to find the coordinates between a spherical coordinate system and in a rectangular coordinate system. Guess what, dog? They've always been equivalent the whole time. So let's try and stay focused.
No, they're not equivalent.
Okay.
They require they're specifically not equivalent because they're not the issue that you have is that your disk only has area on one side, right?
Mm-hmm.
I mean, it can't have area on the other side, right?
Dude, are we going to talk about relativity, or like what are we doing here, bro?
Well, it's just that it's important because if we the whole point of your criticism is that we are trying to discuss an issue that really stems to frames of reference, right? I mean, the whole substance of your criticism against the Sagnac effect and an argument for geostasis, to my understanding, has to do with an issue with the way that we are framing the problem, such that you claim that it creates a preferred frame of reference. But what I'm saying is, we need to agree on a common model in which that can even occur. And projections aside, the ether wind would have kinematics, right? I mean, I wouldn't speculate on the dynamics of the ether wind, but it would certainly have kinematics if it's a physical medium in motion. Therefore, there won't be a kinematic equivalence between a model that is symmetric with respect to the fundamental plane going through the center of the Earth, or the plane of the equator, and the North Pole. So
dude, you are convoluting things so hard right now. It's getting ridiculous, man.
No, I'm just trying to clarify.
No, it's really not. Listen, I'm only going to say this one more time before we either continue the conversation or just wrap it up. So check it out. All motion that you say is due to ball rotate, I'm saying is due to ether wind. Okay?
Right, but you don't.
Buddy, all you have are kinematics. A gyroscope rotating is a measurement. That's kinematics. A ring laser gyroscope is kinematics. That's a measurement. It can't tell you if the ground is rotating or if the sky is translating the motion. You're starting with kinematics. No, buddy, with kinematics, you can't. That's where relative motion is actually true, where we get into the measurements, right? When we
Yeah,
get
but
into
dynamic
stop, please. When we get into the dynamics, I'm saying there's a physical medium that would retard motion that has a periodicity to it. So, for example, the swinging of a pendulum, the precession of a rotation gyroscope, that would be all latitude dependent effects on an ether vortex. That would be my dynamic cause for those measurements. That would be the C plus or minus V measurements that the medium is carrying the speed of light such that it's translating sidereal time down to us. Now, I'm not here. Stop. I'm not here to get into where's the lab frame. Where it's going to be different on a flat Earth than a globe. That's not true at all. You're convoluting it.
It is true. It's 100% true.
No,
because
bro,
the kinematics.
stop. It's a fucking coordinate system.
Yes, it's a coordinate system, and
Stop.
you're aware.
Stop.
You're
If
aware
it's
that the
a coordinate
system is not topologically equivalent, and if it's not topologically equivalent, then it's fundamentally different, and it's not equivalent under a coordinate transform. It's only equivalent under a projection.
Bro, you're not even talking about the same thing right now. We're talking about.
I am.
We're talking about abstract mathematics. We're not talking about the fucking geometry of the shape of the thing we're standing on, man. You have to stop convoluting it if you want to continue this conversation.
I'm not trying to convolute it. I'm just trying to be consistent. If your criticism of the derivation of the Sagnac effect is that we're deriving a particular set of coordinates, your derivation...
An abstract coordinate that could work on a fucking Dorito, bro. Stop conflating it.
So, no, it can't. It can only work in this context if you have area on both sides.
All right. Dude.
I mean, and that's the other problem we have, right?
No,
so it's like,
no. It's not a problem at all. It's an abstract
problem.
It's an abstract coordinate system. It has no physical meaning on a globe or a flat Earth. It's a coordinate system. Stop. That's it. There's no buts, or you can't make it about a globe or a flat Earth, bro. Are we talking the correctness of relativity or not? Do you want to continue this, or are we done?
We have to have a model of reference for your side of the argument.
What's the steel man of my reference? What's the steel man? What's the steel man of my? What did I just say?
You're trying to say that it would be irrelevant what the shape of what we're standing on are, because the coordinate system itself is not exclusive to one geometry.
Yes.
That is incorrect.
It's a mathematical abstraction, dog. It's literally...
I know, and the mathematical abstraction...
All right, we're done.
That shapes have topologies.
Let's end it here.
And the topology is not preserved under the projection. So you have to make a projection to take one frame and turn it into another frame. You can't do it with a simple coordinate transform in which the geometry is the same. You see the problem?
No, because now you're talking about like a map projection instead of abstract mathematics, bro. Like I'm telling you, if this is where we're gonna end it on, let's just end it here on this before it just gets retarded. You're taking it to the biggest non-fucking sequitur. No, dude, buddy, I can't derive your framework. You're trying to stall on absolute space because your framework requires it to explain something that my framework, it's inherent to mine. It's already part of it. Like let's not talk about deriving things, dude. The Sagnac effect derived from the relativistic principles makes no fringe prediction.
Well, but that's the thing, right? So you're alleging that, and I'm looking at the derivations. And it would seem that the issue would just be whether you accept the coordinate system K prime or not that's used to derive the fringe shift. And it's not clear to me that derives from absolute space.
The coordinate system K prime is not what's in question, right? It's the prediction for the fringe shift where the velocity components and the distance components are relative to over C, which is preserving absolute space to make that measurement. That's how that's incorporated in the math. It's not a coordinate system dependent, only works on one thing. This is an abstract mathematical concept that works regardless of what we live on. This is what I'm trying to convey to you, that the use of that, right, is, and he's using an absolute frame to preserve the change in the distance so that they can have the timing offset. Right? And we went over, this is an asymmetrical use of relativity theory. So this is where the actual argument is, not deviating into, well, does the absolute space component work on a globe or a flat Earth? Like, please, either stick with it or just like, let's shake hands and let's be done with it, bro. I had a lot of fun, and I don't want to ruin it on a dog shit end note, man.
Okay, all right, that's fine. I was just trying to clarify between the three models, but I guess let me so here's my issue though, fundamentally. So in your view, how does the Sagnac effect depend on the dynamic ether wind? Because I guess that's that part I'm not quite understanding. So is it still the case that the Sagnac effect, as derived here, is due to the rotation of the interferometer, or is it due to the rotation and its interaction with the ether wind?
Depends on how big the interferometer is and how sensitive it is. So you can have stationary ones that measure what would be called the Sagnac effect, where they say that that's due to the speed of light being measured differently in the east-west directions due to the Earth physically rotating out from underneath the physically rotating out from underneath the propagating light to change the distance, to have the timing offset. And of course, they invoke a fictitious frame at the center of the Earth from there, where they run into the problem where if an observer on Earth is in an inertial frame and an observer in the fictitious ball center is in an inertial frame, doth thou even predict a friendship pattern? But they kind of skirt that to the side and just go with the timing difference anyway. But the second part to your question was where does the dynamic ether come in at? Like, how does that play into it? And the Earth is stationary, and instead of the timing offset being due to the physical ground moving out from underneath the electromagnetic propagation, the Earth is stationary, and the electromagnetic propagation goes a little faster or goes a little slower with respect to the east and west directions, following sidereal time.
Okay, got it. Okay, so the next thing is, so if that's the case, are you now alleging that there is the issue then is that we have a rotation of the interferometer and that produces an observed first order fringe shift? But your claim is that that's not derivable with special relativity, but it's nonetheless the case that if I do take an interferometer and rotate it in the lab frame, let's say, that it will produce a first order fringe shift. And you're claiming a violation of relativity based on that, but you're not disputing that the rotation creates a fringe shift. Am I understanding that right?
Correct. I wouldn't even dispute that linear motion creates a fringe shift. You know me, homie.
Yeah, right. And then we get into Ryoung-Wang and all that fun stuff. But okay, so the rotation can produce a fringe shift.
If this helps you out, can you see my screen on Discord? So when we get into the same situation, right? This is the classical derivation for the timing offset. This is the reduced formalism when you break it down, when you reduce this down. But what we're looking at is the timing difference with respect to the clockwise and counterclockwise rotations, and then length of the apparatus, velocity, and then the quadratic term is too small, it cancels out. So what they're left over with when they reduce all this down is your timing difference is equal to 4 times the path length times the angular velocity over c times lambda, which is going to be your change in wavelength, essentially is how they're describing it for the fringe pattern. Now, when you look at this measurement, right, you're like, where's the, because I didn't know this either, right? This was like new to me figuring this out, how this works and what this means. What this equation means is that this measurement, the velocity and the distance components are with respect to C's inertial frame. And what that means is this is just an abstract coordinate system that preserves the distance and time so that this measurement can be made. And with that, it correctly makes the correct prediction, because the speed of light does not complete the circuit traveling at the same speed with respect to the change in distance with clockwise and counterclockwise. It completes it, a little faster or a little slower, and that is facilitated by the preservation of absolute space to make that that timing difference.
Okay.
So does that make sense now?
Yeah. So I see what you're saying.
So yeah, this like derivation has nothing to do with the shape of the Earth. It's a pure abstraction, and that can get very confusing because it's like, okay, we're talking dynamics. And sorry, I got a little irritated with you. It was just like, it seemed like you were trying to,
No, it's okay.
seemed like you were trying to get out of the conversation and just like force it into something that didn't matter. And it was just like, why doesn't he see it? But this is actually, you know, it did take a, you know, this is the implication or whatever. And, you know, if you're not familiar with it, but yeah, when we were talking dynamics as well. So we're talking like, you know, real forces, where's the lab frame? So I can kind of see how you were getting confused, but in this particular instance, in regards to that, we're just talking arbitrary, mathematical frame to make the prediction. And then when you get into relativity, sorry, I'll let you go. Go ahead.
Yeah, no, go ahead. Finish.
Okay. So for the relativistic derivation, if you follow, if you actually try to satisfy Lorentz symmetry, the change in time and the change in distance won't equate to anything because the speed of light is constant for the inertial observers, meaning the rotating source and the rotating recorder. So the speed of light is going to complete its circuit at the same time, and there's going to be no fringe shift pattern predicted. And this is actually specifically in reference to Millikan's paper. So the guy that you referenced, and how he only used a half a Lorentz symmetry, accounting for the timing difference and not the link contraction component, you know, an invalid use to satisfy the equation. That's why when you get into the history of the Sagnac effect, you'll find that there's, you know, 20 plus different derivations of it, but they all run into the same fundamental issue, because without invoking that fictitious coordinate system and assigning imaginary vectors for electromagnetic processes, you can't explain it.
And the fictitious coordinate system, just to make sure we're clear, that's the in Millikan's paper that would equate to K prime, the co-moving frame of reference of the interferometer. Sorry, am I still sharing? Oh, no, I was gonna.
Sorry, I have my mic muted. No, where it says, where it has the distance and rotation component over c squared, that's the reference to absolute, you know, for the abstract to make the prediction for the measure for the rotation of the apparatus. So K prime is making a measurement with respect to absolute space because it's describing that rotation rate within K prime, but the actual measurement is made with respect to absolute space, which is denoted by that over c squared component. And and then when he's introducing the lab frame in itself, that's just the lab frame also makes the correct prediction for C plus or minus V, but that's you know, not an issue. So let me show you. So let me show you this real quick. So when you get into something like the Wang interferometer, where he's doing this top portion here, suppose you wanted to try to answer this with relativity theory. You see how I have two red circles right here on the sides? So this would be, if you were to do the classical Sagnac equation, which is denoted here, delta phi 4 pi v nu delta L over C lambda. So this is going to be, what this would define essentially is this would say, okay, we have a fixed reference point here and we have a fixed reference point here, and we're going to account for the distance traveled here, and that'll give us the timing difference for the fringe displacement based off of that distance. So that would be kind of how you could conceptualize what this equation represents by assigning imaginary vectors to points in space. So this interferometer would just be moving in a lab frame. So we would mark these as our points in space that it's using. Now, if you were to take the relativistic approach to trying to answer this, now remember, we don't do fictitious frames and imaginary vectors in relativity theory, so we can't benefit from this, but we can take a symmetrical coordinate system transformation by invoking a cylindrical coordinate system to be at the midpoint here and invoke a relative midpoint. So now this red circle here is going to be our midpoint observer in relativity theory, and he's going to watch the inertial observer, or I'm sorry, the inertial observer in motion here make this measurement with respect to these 2 points. Does that make sense?
Yeah, I think I see what you're saying. So I think the practical upshot of all this, though, would be that the speed of light the real point of contention is a difference between whether we consider the speed of light constant or not.
It's
And
one of the
my
most
question
fascinating
is-
illusions in physics.
Yeah, totally. And so the question is, though, that I'm wondering if the speed of light, when you are moving, you're always moving in reference to this ether that is dynamic, right? And to the in your view, the absolute lab frame. So does the speed of light have anisotropy based on movement, even when we consider it in reference to the moving ether?
No, explicitly not. And this is actually noted in GPS. This is how they derive velocity for moving receivers based off of the variance in the speed of light. They attribute it to, I'm going to pull up a citation here from an ICD, which is a interface control document for GPS. Give me 1 second. Let me remember where I put that. I think it's in my GPS Prezi down here at the bottom. So what we're going to be looking at, what Ruyong Wang pointed out in a paper in the 2000s, was how irrespective of motion being rotational or linear, GPS makes the correct measurement based off of a timing difference based off of that velocity using the range measurement equation, which is the same equation that's used for sonar and water, except at this time they're using the vacuum propagation speed of light. But what we have here in the ICDs from GPS is that they talk about how they derive the velocity component, and they say that this is due to a Doppler shift or frequency from the receiver that's proportional to the relative velocity of the receiver with respect to the satellite along the line of sight of the receiver. So when you, in order for the wavefront to be different for the moving observer, the speed of light is going to have to be measured moving as c plus or minus v with respect to the direction of motion, with respect to the the satellite where that direction was coming from. So if the motion is going with or against the signal essentially, and in conjunction with Earth rotation and or ether wind rotation, which would have the same timing offset, which is exactly what Wang was talking about in regards to the velocity component aspect specifically. So yes, that is fully measured and accounted for.
So let's see, one moment.
It's like, because if you think about it, right, like the speed of sound, right? Nobody argues that that's constant. If you're in like motion, you can measure the Doppler shift, and that's facilitated by that change in that wavefront, and that would only happen if you're measuring it, faster or slower. You're not measuring it at constant speed, irrespective of your speed. So what this shows is that electromagnetic propagation is just like any other wave, and you can use it to measure velocity, even if it's linear or rotational. And in addition to that, you can determine from Doppler shift if a frame is truly stationary or if it's in motion or not. So you can actually use these measurements to make definitive refutations to the postulates of relativity theory that say that all reference frames are equally valid. If they were all equally valid, then you couldn't use Doppler shift and the timing differential to establish the distance between moving observers and non-moving observers.
So that's interesting. So there's a couple things here. I'm curious because the implication of all this is that, I mean, if I'm understanding this right, there's not some effect of the ether that prevents a V plus C with the observer, right? So if I'm on an airplane and I'm traveling at, I don't know, 500 miles an hour, let's say, then and I have some experiment involving light, let's say, and I shoot the light forward within the frame of the airplane, let's say, there'll be an additive effect on the speed of light due to the motion.
Yep.
Okay. And Do you still hold that the permeability and permittivity are related to the speed of light as 1 over the square root of the product?
Yep, that is the calculated speed for light.
Are permeability and permittivity constant?
For the measurements that they have it down to, I think it's the 12th and 14th decimals respectively. That is where they say it's, you know, quote unquote constant, right? And then from that, there's different levels of, accuracy or whatever, right?
Yeah, I'm just curious though, because just doing it, and you know, I'm not a physicist by any means, so correct me if but this is just what I'm thinking here. So if you have now that relation, right, and we're taking 1 over the square root of mu 0 e 0, you set that equal to c, right? Well, now what you're saying is what we have. So there's an observed base speed of light, and then it varies as a function of how fast we're moving, right?
Well, I don't know that there's ever been an observed base speed, right? It's always measured c plus or minus v a little bit. The calculative value for those, for the permittivity and permeability, gives you the speed of light value, but on Earth, relative to the lattie, it's always measured plus or minus v with respect to the east-west orientations.
But okay, so the right side of the equation then is something that we can call, let's say we set c equal to, I don't know, c naught plus or minus v. And c naught might not be observable, because what we observe in practice is the plus or minus v term. Is that c though is not constant, right? Because it varies as a function of velocity.
Correct. That's where you get into that analysis earlier when they were using over C, right? So their interpretation was that C has its own inertial frame, and that's where it propagates at that speed. And that speed is the actual baseline with respect to the wavelength changes that all motion is relative to. So I do accept that calculative value as C that it propagates there, you know, that would be C in its inertial frame, and deviations from that are what we measure.
C in its inertial frame.
Yeah. So, you know how we talked earlier about how they defined the distance component and the velocity component over C squared, and that's just relative to some coordinate system. So similar situation here.
Got it. I'm just curious now. So the right side of the equation then, what do I write for this when I take 1 over the square root of the permeability and the permittivity? What do I write there? It's not a constant, is it?
You don't have to make any changes to it. You can use that as your constant for your baseline. Physics works off of ratios of constants, whether or not that constant is even true or not in some cases, right? So when you have that as the baseline and you're measuring everything out there, or, you know, from that point, you're setting that as the threshold, it's just as good as a constant. I accept that as a constant value for the baseline of all motion to be relative to with respect to those values.
So there is a underlying constant speed of light, or no?
Yeah, I accept that calculative value as a constant, right? It's
Where is
measured.
that-
It's
where is that
measured
measurable?
nowhere. It's always measured C plus or minus V relative to that threshold.
Can you demonstrate that?
Any interferometry experiment ever done that you would cite as Earth rotation.
But it would have to work all the time, right?
Any GPS measurement that requires a quote unquote Lorentz rotation, which you would attribute to Earth rotation, I would attribute it to a timing offset for ether wind.
Okay, so let's go back to the idea of a stationary lab frame. So we have a stationary lab frame assumed in your model, right? Or not assumed, but asserted, let's say, on your side, which you provided evidence. So now let's say we we set this experiment up. We take, because it's stationary, by definition, there's no motion of the reference frame itself, right? Anything that is measured as such, in your view, is due to a relative motion to the ether wind, which is then communicating to objects in the lab frame. Am I understanding that right?
Sounds pretty good.
Okay, so now I take clock 1 and emitter 1, let's call them C1 and E1, C2 and E2. And I separate them by a distance of, C1 and then emitter, and then C2 and a receiver. With me so far?
I'm sorry.
And
You
we'll
have
separate them with a distance of D.
Okay. You have two clocks separated by a distance D. Are they in sync or no?
Yep. Well, that's the question now, right? So if I shoot a beam from one side to the other, it ought to be the case that we can perfectly synchronize these clocks because they're not in motion relative to each other. There's no differential dilation due to a difference in gravitational potential, and there's no error in the synchronization as a function of movement, right?
Yeah, I see what you're saying. So basically classical Einstein clock synchronization, right?
Yeah.
Okay.
So but now it's trivial. I just shoot a beam from clock 1 in emitter to clock 2 in receiver, and I can easily now measure speed of light between the two. And that speed of light is going to be c, correct? Or we could call it c naught. So the functional speed of light observed in general is c naught plus or minus v.
Yes.
Okay, so we ought to be able to measure c naught in this fashion, right?
Yes.
Do you have such a measurement?
Yes. In the 80s, when they were doing atomic clock testing for the GPS system, when they were establishing all that, they were specifically testing classical Einstein synchronization. And what they found was that they had to set a Sagnac timing offset correction that was noted from Subarai and others in 1986. And then there was another one, I want to say Jafari or Jeffrey, something like that. I'll get the name for you here in a minute. But your boy Jeffrey, they they sent a clock to Tokyo by plane, and they had to account for a quote unquote Earth rotation Sagnac effect correction, which I would scoop up as ether wind rotation. So basically, what's happening here is in the same way that interferometry measures a periodicity in the minimum maximum speed of light throughout the day, so do these atomic clocks, because they're so sensitive, breaking a second down to 9,192 millionths of a second. These factors start to take effect and have to be corrected for. So that so when you move a clock with respect to a stationary clock, that effect is measured and accounted for.
So, but what I'm asking now is that, it ought to have been the case. Ruang Wang has written the paper about GPS, right? And then I know Ron Hatch did some work in that area as well, correct? I haven't, there's that paper, Those Scandalous Clocks. Was that by Wang or
Dude,
Hatch? I forget. I think it was both, right?
That was by Hatch. That's an excellent paper.
Yeah. I'm just curious because, either Hatch or Wang seems to be of the opinion that the one-way speed of light is measurable. So I'm just curious if it was the case that the one-way speed of light was measurable, and I know that they've sort of derived this from the one-way receiver data, and then there's a difference in interpretation of the Sagnac correction, and the claim would be that it's not relativistic. But why isn't it the case that we can just easily set up a one-way speed of light experiment in the lab frame with two clocks as described and measure C0 consistently? Well,
I'll do you one better. We can actually do a first order measurement of the wavefront change using a phase conjugate mirror. And so measuring the Sagnac effect using a phase conjugate mirror, which if you're not familiar with what that is, can you mute for a second, the feedback or the static?
Oh, I'm sorry. Yeah, I keep forgetting that it does.
You're good. What the phase conjugate mirror does is it sends the information back in the. I'm sorry. It like if the wavefront changes. Actually, let me start over for the audience so everybody understands what this is. So with a traditional mirror, suppose you're going to shine a laser at it, right? The wave is going to hit the mirror and it's going to change. And when it bounces back and you make your recording, you don't know if the wavefront was changed before it hit the mirror or if when it hit the mirror that caused the change, right? There's ambiguity there. So you could say, was the speed of light constant the whole time en route, or did it travel at a constant speed there and then did it instantaneously appear at the detector or vice versa or something like that, right? So what you could do with a phase conjugate mirror, this is a special type of mirror that reflects the wavefront back in its original orientation. So an easy way to think about it is sending the wave back in time. Now, obviously, I don't take the position that the wave's time traveling or anything like that. This is just a way to conceptualize the what's being read there, like in terms of preserving the change in the wavefront. So earlier I talked about how in GPS you can use the Doppler shift to measure the velocity of an observer. And this facilitates a change in the wavefront, which facilitates a change in the speed of light. Otherwise, there can't be a frequency change for there to be a Doppler shift because the frequency and wavelength have an inversely proportional relationship. So they have to change with that C plus or minus V relationship. But getting back to the mirror, we can actually see that wavefront change because the phase conjugate mirror will preserve that orientation. So when they do that and they do the reading, so this is essentially a one-way measurement. When they do that, they find that the wavefront is already changed en route before it hits the detector. So that's a first order measurement of the speed of light being different. And then obviously again with GPS, the speed of light is measured differently. When you get into Petit and Wolf in the 90s, where they went to analyze raw GPS data and found that it was already corrected for the Sagnac effect to make the speed of light constant. What that is that's a first order timing correction to the speed of light. So all GPS data, shows that the speed of light is measured C plus or minus V. What's really interesting, right, is that the calculative value for C that's asserted as a physical constant isn't measured or utilized in reality as that physical constant. It's being utilized as a constant where things are plus or minus relative to it, rather than it being as an actual physical constant. When you get down to the precision timing measurements in interferometry and GPS. And I think that really shows that the Einsteinian interpretation of not using absolute time and space for imaginary vectors and all that was a huge mistake, because actually in GPS, the coordinate system transformations from the ECI to the ECEF are actually facilitated by Galilean transformations, which are absolute. So in other words, relativistic physics doesn't exist in GPS, and it works off of equations that derive the Sagnac effect in the first order, which we know is the first order effect, and relativity, makes a different prediction for that without invoking a fictitious frame that violates its postes, to account for a measurable variance in the speed of that's why it's so important, right? Because it's invoking a fictitious frame to explain a measurably physical difference in a theory that asserts constancy. Right, we're looking at a fringe shift pattern difference, and it's like this theory predicts constancy, so there should be no fringe, there should be no timing corrections and all these things, but yet they exist, and they show that the interpretation of C plus or minus V with respect to a stationary lab frame, it makes the correct prediction, and that can be all facilitated by a dynamic ether wind.
I see. But the ether wind itself doesn't ensure in any way a constancy of the speed of light in any practical sense, right? There's still always an additive component of the velocity based on reference frame.
Yeah, that's not a problem for me.
Okay. So yeah, I mean, going back to this clock,
that was my premise. Remember?
Yeah, I got you. I just wanted to clarify that. So when it comes to the one-way speed of light measurement, so you mentioned like phase conjugacy and all these other things. my understanding is you ought to just be able to do a very simple measurement as I described. Yet my understanding is such a measurement is not done. Does Wang have such a measurement within the lab?
Oh, dude. Oh, okay. So you're saying use atomic clocks to time a signal through a medium, right? Like, so basically an interferometer. There is, dude, it would be so awesome if that was repeated, because in the 60s, that's exactly what Pound Repka and Pound Snyder did, 1960, 1965, respectively. They were measuring a frequency shift in electromagnetic radiation, which could easily be attributed to an equivalence of C plus or minus V. And they were like, you know what, we should continue this experiment with atomic clocks at the top and bottom of the tower, so we can get that timing offset and see if the interpretation that C plus or minus V caused the frequency shift, or if it was due to the gravitational field of Earth and the constancy of C. Which would be a great experiment, and nobody ever followed up on that. And those two gentlemen were awarded a Nobel Prize or something for confirming relativity theory, but they never actually gave a meaningful confirmation of it. Mike's unmuted because of that. Because of the way the detector works for what they were using, it couldn't differentiate between the wavelength change and the constancy. So all it could measure is basically due to a frequency change, and then it would ionize that and convert it to an electric signal. And based off of that energy produced, they could determine the energy change. But that doesn't tell them if the speed of light is constant or if it changed due to C plus or minus V. But they, with that specific reading, you would need an interferometer. You would need to induce an atomic clock, like you were saying. Those would be great ways to make an actual physical measurement. And they've never done it, not once. And those guys were given, like I said, they were rewarded heavily to present this one-sided interpretation of it. But Wang actually wrote a paper in 2021 or 2022 where he showed like 20 or 30 different configurations where you could use a fiber optic gyro in different orientations using atomic clocks as well, and different material media for it to propagate through as well, to make predictions. But yeah, no one's ever done it. And I agree with you. It would be a badass experiment if somebody followed through on that, because that would be super definitive and easy to understand and interpret. But yeah, it's never been done.
Yeah, I just find that odd. I don't know. I mean,
me too.
Yeah, well, I mean, it's just interesting because, correct me if I'm wrong here, but I mean, the whole reason that, if you were to attempt such a measurement, the view of relativity would be that because of the lack of clock synchronization, you're not able to actually affect such a measurement, right?
No, we don't have, or relativity has no problem with two stationary clocks synchronized. Neither does the lab frame theory. And there's no problem with that. It's when you introduce motion of the clock as well that will cause desynchronization.
I thought that there's an issue there, but
No, what was really interesting about Einstein synchronization, and this goes for any clock synchronization really, and this is what Louis Essen found, the inventor of atomic clocks, who came up with that technology, using the conversion of cesium and electromagnetic waves to match the resonant frequency of cesium to then be ionized into a frequency that gets outputted into that 9,192 millionth frequency rate for the electric conversion. But what he found was that sometimes the clocks go wildly out of sync for no reason. Like they don't have any causal mechanism or anything like that, but they're really easy to make corrections to. So they can account for that sort of stuff and the deviations from that, and like reset it back to that natural oscillation rate of the cesium because of how malleable it is. I don't know if that's the right word, but how easily they can make changes to it to keep it in sync. So yeah, 2 stationary clocks in the lab frame, no problem there.
Okay. Interesting. Log synchronization and the one-way speed of light. Yeah, I guess I need to look into some of this more. I guess my issue here though is that, so is there is the permittivity and permeability are defined in reference to a baseline speed of light?
I mean, that is the calculated value that it gives. So, yeah.
And also that value shows up in the later derivation of the Maxwell equations, correct?
Absolutely.
In Ampere's law and Faraday's law.
Absolutely.
So I guess I'm just curious because it would seem to me that if the speed of light was variable, then it ought to be the case that those measured physics would also vary as a function of velocity. And I guess I'm not understanding how that's avoided in your framework.
It's not at all. That's exactly what happens. It happens on really small degrees where it's something that's going to affect things. And when you get into very precise measurements using interferometry or GPS specifically, that's where you're going to have to start accounting for these variations. So everything. Go ahead.
Sorry, go ahead.
Yeah, I was going to say everything, works as normal. And like I said, when you establish that constant with those variables and have everything relative to that as the baseline, whether or not it measures plus or minus that, if you're using that as the baseline, it's just as good as if it was that, right? Because it gives the correct measurement. And when you get into starting with Fresnel drag, which was mathematically derived in 1818 with the prediction that the density of the ether would be proportional to the square of the refraction index, and then that being experimentally measured by Fazal in 1851, I think it was. And then building on from that, they did, what was the other one they did? I think they went from Fazal to Michelson-Morley. So whatever they did in between there, they realized that they could measure, using those values, because Maxwell came a little bit after the prediction. So they already had that calculative value somehow. And then when Maxwell attributed permittivity and permeability to it, they were like, oh, it's, experimentally confirmed that this is a conjugate expression of the two or whatever. But they were already using that baseline to make these measurements. And then when they got down to Michelson-Morley, the equation that they used is the same equation that's used in, modern ring laser gyros, et cetera, for deriving velocity. So I have no contention with that being the calculative value, that being the quote unquote constant value. But when you get into the actual measurements of it, it's always measured plus or minus relative to the lattice and direction.
Yeah, I'm just curious, so are you familiar with what's your view on experiments that have been done with particle accelerators and like muons, for example?
That's a great question. So when you get into muons, right, you get into an invalid use of relativity theory. You get into an asymmetrical violation. They'll talk about time dilation of the muon in the lab frame that's being measured, but they won't talk about link contraction of the lab frame. In other words, when they talk about muons at altitude, right, they'll say in the muons reference frame, it's moving at relativistic speeds. It's experiencing link contraction and time dilation. And from its frame, it appears that the Earth is accelerating towards the muon to compensate for that link contraction. But what they don't do in the lab frame analysis when they're measuring muons and particle accelerators is they don't ever assert that the lab frame is rushing towards the muon, because that reveals the kinematic difference between the two frames. And because there's no symmetry used in that analysis, applying special relativity as a mutually exclusive interpretation of a muon and what it does in the lab is an invalid use of it. Just purely off of the mathematical framework of the theory, right? Like not even getting into anything other than just not fully satisfying covariance in a meaningful way to provide actual invariance, which is required, which is supplemented by symmetry of link contraction and time dilation.
Yeah, I'm just curious because I'm aware of a measurement that has been done, because I wasn't actually referring to that aspect of muons. Let me see. I'm trying to find the exact experiment. Sorry, give me one moment here.
The G -2 or whatever.
Perhaps 1 second. Let me try to find it. Let's see. Okay, let me pull out this and okay. Yeah, that would be the one, I think. Let's see. No, that's not it.
While you're looking that up, I'm gonna go grab some water. I got hella cotton mouth.
Okay.
All right, I'm back. Did I miss anything?
Nothing exciting. Only thing is I think Franco wanted to come up. I don't know if you wanted to bring him on as well, but up to you.
Absolutely. Send him up.
Yeah. Cool. Because he had some questions that he had posted. And
nice.
Yeah. Let me just wrap up from my side, though. I guess, so I want to do some more reading. I'm sure you could send me some more papers on this regard, but I guess when it comes to geostasis specifically as it pertains to this stuff, so it would seem that the claims as they pertain to the Sagnac effect are that rotation still causes the Sagnac effect, but what's observed in what is attributed to the rotation of the Earth is actually an ether wind, right?
Yeah, especially because there's no north-south variance. So that eliminates the causal mechanism under the current paradigm where the Earth is physically, moving out from underneath the light to produce the difference in distance. So if there's no north-south variance, then there's no Earth rotation. And then there was another part to your question. Oh, that the Sagnac effect was explicitly due to rotation. Although we didn't get too much into the Wang stuff or the measurements, I would argue that it's due to any motion, linear or rotational, but otherwise good to go.
Yeah. Yeah, I'm just curious here. So, and then there's a claimed effect on the precession of gyroscopes, right? But gyroscopes precess in accordance with latitude. So is there a difference between a ring laser gyroscope measuring this effect and a physical gyroscope?
Nope. The retardation of the gyroscope mechanical would just be due to the ether wind relative to the lattice at that because every lattice is going to have a different velocity, and the ring laser measures the exact same thing.
Okay.
Only more precisely.
Why doesn't it affect other objects in motion?
I've thought about that for a while, and I think things that are oscillating may be a special type of motion, right? When you get into a pendulum and when you get into a gyro that's rotating, you get you get this effect, this drag effect that causes a precession that, is only present in those, or, when those are when you have a pendulum swinging or when you have a gyro spinning. When you have a stationary pendulum, it never, starts moving on its own or anything like that. There's never anything acting on it, but it's always like a retardation with respect to any motion, I would guess. But you could actually, when you have something that's oscillating where it has like a periodicity to it, you can actually map out those fluctuations. Like, I forget what it's called, like a spirograph or whatever, when you map out the pendulum. Like, my interpretation of that would be that's mapping out latitude dependent toroidal geometry based on the velocity of the ether wind at that latitude, and the retardation that it's or processing to due to that is like that's what it's like drawing when you make the spirograph with it. That's what I think.
Yeah. Okay. That is kind of odd to me, but because like and here's the angle I'm thinking of it from, right? Because we agree that, so let's go to the lab setting, right? If I have a turntable and I place a mechanical gyroscope on the turntable and I rotate it as it's spun up to, I don't know, 10,000 RPM, whatever, then it's going to register rotation in accordance with the rate of the table. And because of the effect that we talked about, whether regardless of how we derive it, an optical one will display the same precise rotational effect, right?
Mm-hmm.
But now, when we place them in a state where they're not being rotated, by us, but we have sort of like what should be stationary environment, they read the same way that they would as if they were being rotated on the platform. So, I mean, inductively, we can establish that the two recorded, why would it be the case that one type of recorded precession or interference pattern is due to the rotation of the reference frame, and the other that measures the exact same way on a slower scale in accordance with a rotation, we have a difference in opinion of the cause of the rotation, why would it be the case that there's a different mechanism for one type of rotation measurement versus the other?
Yeah. Well, you have a kinematic, like what we're dealing with, right? The gyro and the other gyro, Mr. and Mrs. Gyro, right? Mechanical and optical. Um, those are kinematics, right? Those are measurements. So when you have them rotating and they're, preserving their orientation with respect to absolute space or making the measurements or whatever, right, of the rotation, and then you put them stationary and you say they're following the same precession. So wouldn't that mean that, like, wouldn't the logical inference be that the Earth is causing that rotation? And I would say, sure, that's a perfectly valid analysis to assert, right? And then, like, how could we experimentally falsify that or like do further testing on it? And it's like, well, we could look for north-south variance over long distances, GPS or larger interferometers that are used, like Michelson Gale Pearson, the one in Christchurch, the one in the 1990s that was done in New Zealand. I'm sorry, Australia as well. You could use different ways to see if there's a north-south variance, and on top of that, if there isn't any, and also if there's if it increases at altitude, etc., right? You could do different things to establish what the causal mechanism of the measurement is. So just doing it off of one measurement like that wouldn't be a valid way to come to the, because if you do induction, right, it's like, yeah, you came to that conclusion, but now we have a bunch of things that go against it, and so like that's why that's not a valid way to look at it. And there was one other thing I wanted to mention that I can't recall, so I'll yield.
Yeah, okay. That's I appreciate the way that you approach that, because I mean, it would seem to me the simplest explanation is the rotation of the reference frame in both cases is the cause of the phenomenon. Regardless
Yeah.
of whether, regardless of whether the relativistic explanation for the Sagnac effect was consistent or not. Like, even if we grant that, right?
Well, either way, if the rotation was due to the motion of the Earth, right, there would have to be north-south variance in that regard. And then in addition to that, you can get into a dynamic energy analysis, right? So you can take the reference frame of the pendulum and do a kinetic energy analysis. And if you try to make the Earth do the work for the pendulum, you end up with a kinetic energy that's astronomical. That's not what's measured. When you do that same analysis with respect to a stationary lab frame and you just use the mass of the pendulum ball, you make the correct prediction for the kinetic energy, and you can satisfy conservation laws that way. So that's one way. Dynamic analysis is a way that you could show that the Earth is stationary and it's not actually the causal mechanism of the pendy, because if it was, it would have a different kinetic energy potential.
That's what you sent me from Bennett, right?
Yep, and you can actually apply that to anything: airplanes, dudes falling out of planes, dude walking down the street, all kinds of different scenarios, linear or circular.
Well, I haven't looked at that fully. I did see that you sent it to me, so I could take a look at that. But
Yeah, definitely. Because if we're going to be asserting that the causal mechanism is like the mass of the Earth, the rotation and all that entails, we're going to need a substantiation of a dynamic analysis that shows that that reference frame is even valid to begin with. Otherwise, all experimental evidence, contradicts the narrative that the Earth is a non-inertial frame.
yeah, like the whole thing here that's just curious to me is that I don't see the need to invoke a new mechanism. And I get what you're saying about the pendulum, and I'd have to evaluate the specifics of that, in terms of, like, to what extent that analysis makes sense to me. But like, we have a perfectly valid explanation, to my mind, that's replicable and demonstrable, and we can make predictions on what ought to happen. And we do have a latitude dependent effect that's measured on the precession of gyroscopes and on the precession of pendulums, although to my understanding, the relationship's inverted between the two. So all of those pieces seem to fit together, and it's not clear to me. I mean, I understand that there's something about resonance, but this idea that motion is like, there's like because what you're saying is that correct me if I'm wrong, but this is how I'm thinking about it now. So the ether wind in some sense provides a torque or like friction to the gyroscope, and because of that, the gyroscope will precess in, I believe it's 90 degrees in the opposite direction of the applied torque, right? Is that sort of your hypothesis, or?
Yep.
But how would we ever measure that?
Well, it's just a measurement. You would have to do other things to substantiate it. The measurement itself can't tell you, remember? That's just kinematics. Now, you said that, like you were saying earlier, though, the latitude dependent variation in C or gyros, etc., isn't mutually exclusive with an ether wind providing that mechanism. Where we would deviate on the actual prediction would be a north-south variance. So, if the ether wind is, doesn't, my prediction for our model is that there won't be a north-south variance because you're traveling perpendicular to the flow. So you're not going to have a C plus or minus V, whereas Earth rotation would be you're in a physically different location, which is going to facilitate a measurement in the speed change. And it's never been shown in the north-south orientation ever.
What do you mean? Like, if you have a gyroscope and you're moving relative to latitude, you have a latitude dependent effect. I'm not sure I understand the distinction between
Yeah.
latitude dependent effect and a north-south effect.
Yeah. We're talking about interferometry measurements with light. So when they get the fringe shift pattern that measures quote unquote Earth rotation, that fringe is only facilitated by the orientation of the arms that are in the east and west directions. The north and south directions do not display any fringe measurement. You can have an interferometer orientated north-south and it produces no fringe. As soon as you turn it east-west, that's when you get the fringe shift pattern that produces the measurements. I mean, this is going all the way back to Michelson Morley, Michelson Gale Pearson. This is like what it's all established under. And then even in modern times, when you get into GPS, where you have electromagnetic propagation over long distances, there's no north-south variance accounted for either, which in the current interpretation, is that there's going to be a timing difference because you're physically in a different spot than when the signal was actually sent, and they don't make any north-south corrections. So that's like a falsification of where we deviate, right, on our predictions as to the causal mechanism. So when you say like we don't need to assert a new mechanism, well, this is actually the only mechanism that has only ever been proposed and measured. It's just been renamed as Earth rotation.
Well, that's interesting though, because like modern navigation systems use, for instance, an axis of three ring laser gyroscopes, right? And those are measuring we agree that those measure the pitch, roll, and yaw rotations of the craft, right?
Mm-hmm.
But it would seem to me that from my understanding, there is a drift adjustment that's done based on latitude and the relative motion of the in this case what I'm asserting is the rotation of the Earth. So are you saying that there would be a direction in which I could fly an airplane and align the inertial navigation system and not record a drift? Like it's going to vary by latitude. I think
Oh, sorry, I had my mic muted. Yeah,
Okay.
You're not going to have any anything going in the north south. Like you'll still have your velocity correction for your actual velocity and rotation and roll and all that, but you're not going to have an ether wind latitude dependent correction.
That's odd. Do you have a like, is that something that's borne out in technical manuals? That the drift depends on the relative orientation to the, what for me would be the rotational axis of the Earth. So you're saying if you're parallel to the, I'm trying to think what the equivalent would
Well,
be that's it's non-specific to a rotating model. Like,
well, you got to think
if you're moving in a
too.
direction that is parallel to a line of longitude.
Well, you got to think too, it's a 3-axis measurement on the combined output. So it's going to take everything, averages it out, and then your output is going to be a solid 15 degrees per hour. So you're not even going to know about any deviations, plus or minus anything on the output, just using it as a user. There's a whole internal computer system that runs a Kalman filter that accounts for different corrections and
Yeah, I'm aware.
coefficients that have to
I'm familiar with column filtering, but
right that have to be applied. So you're not going to, and we don't even know really what all is like programmed for the corrections and whatnot. But
that's you can verify that.
But what we do have is the output, right? And if you're taking 3-axis gyroscope readings, that output's just going to give you 15 degrees per hour no matter what. So it's not going to be the device you would use to make definitive claims about this. You would need, so like, for example, when you get into Galev's work, where he had an interferometer that was with a specific shielding even too for the arms, when he would orientate it north south, there would be no variance in the speed of light. None of that sidereal rotation measurements or anything like that. But then when he would turn it east west, that's when he would get the measurements. That's when you would get the turbulent to laminar flow. That's where you would get all these measurements from. So, and again, you're not like the mutual exclusivity claim here isn't latitude dependent corrections, right? Like that's whatever on both models. What would be substantiating Earth rotation as the causal mechanism would be a north-south variance, and that's never been observed.
A north-south variance. So, I'm still. Can you so with inertial navigation specifically? Can you provide a reference that there's a difference between because there is a drift that's observed in inertial systems, like that's certain and known, but it would seem odd that you can't, I've never heard of a lack of a drift as a function of your alignment, except on the fact that the only one that I'm familiar with is the latitude dependent effect.
Lack of a drift.
Right,
Yeah,
because you're saying north-south variance, right? So
and like I said, in terms of the output of that apparatus, it's not going to tell you anything about that, right?
Right, but I can build my own. I mean, maybe not a ring laser gyroscope, but I can take the raw. I mean, I can see what's available and see if I can pull the raw data and apply.
So there's a YouTube channel called Plenum 88. He built his own Sagnac interferometer and did the measurements as well. And part of the orientation when he sets it up north south, there's no variance. So that's another one you could look at as well.
Right, but this principle is not mentioned in any. I've read quite a few.
Yeah, it doesn't matter if it's mentioned. It's a measured effect, and
right. But why isn't it mentioned in any of the manuals?
That's not a valid answer to the measurement that exists and isn't accounted for. Right.
Yeah, but it's just you're claiming now that I mean, correct me if I'm wrong. If an airplane flies parallel to a line of longitude, because I'm trying to keep it model neutral for the sake of
parallel to a latitude, so it would be going. You mean perpendicular to a longitude, north south, bro.
Oh, I see what you're saying. Okay, so if we're flying perpendicular to a longitude, to a latitude,
Yeah, you're
we
not going to
wouldn't
have
record a drift.
you're not going to have any rotational variance. No. You can build the dude. There's a guy on YouTube that built his own interferometer and did it. Like it's a well-known component. I mean, this exists in GPS as well. Like it not being in the manual or not being accounted for isn't an argument. If you want to move on or something, like we can, but just saying that, like, denying the measurement's existence because it's not in the manual isn't serving anyone as an actual argument.
Yeah, but I just find it odd because it's like you would have to program it into the system, right? Because it would have to know its alignment, and the way that we determine heading is through gyrocompassing, right? So I don't understand how you could maintain heading, and because you're not using, I mean, like, okay, so older gyroscopes use like slaving to a magnetic compass to maintain heading, to maintain a consistent reference, for example.
If I could interrupt real quick, I can answer this. It's the INSs are 3-axis gyroscopes, bro. So it's taking it from three different axes and giving you the average. So you're not going to even be concerned with a difference in the north-south variance, right? Because it's going to give you an average anyway of what they expect, and all that's going to be calculated on the within the system itself. So when you don't have to program in anything, like it's already calibrated. The only thing you program into it is your lat, longs, and GPS coordinates as many decimal places as possible.
No, you only record the latitude and longitude when you're doing determination of initial heading.
I'm saying for booting it up and using it and getting it started. When you do that, you enter your latties, your longies, GPS coordinates, as many things as you possibly can to get a fix. So then so it knows, where it's supposed to be, what output it's supposed to have. And then using the 3 axes to, get the average, it's always going to output what it needs to function, within that coordinate system. So the fact that it's not in there isn't a big deal. It's not a mystery, where this is an actual effect that you could look at yourself and know about. Like, not knowing about it from the manual doesn't mean anything right now.
Yeah, I'm just trying to think about this. So I mean, in with respect to like gyrocompassing though, like a gyrocompass has a single axis measurement, right? But if are you saying that you have to be like, how would you know? Because when you do your calculation of initial heading, you don't know your orientation. You know, I mean, that's the whole point. That's why you use gyrocompassing.
You're talking about different things though right now. You're talking about making a heading versus a measured variance in the speed of light when in a north-south orientation. So it's not really the same thing.
Well, I thought you were saying that you wouldn't have, maybe I misunderstood, but what I'm saying is that when you travel north to south, you're still able to pick up a drift that varies with latitude, regardless of orientation to the axis of rotation.
Yeah, you're using a 3-axis gyroscope, Brody.
Yeah, but I don't think
no, bro, it's in the east-west directions, dog. Like it's a moot point. That's the purpose of the 3 axes. You're never not going to have that drift on there. That's what I was telling you. That's what I was saying with the guy on YouTube, Plenum88. Shout out to your boy. Does a single axis gyro in his lab and shows that when you orientate it north-south, there's no variance. Right? That's the only thing that's relevant to this. Not plotting headings or anything like that. We're talking about measurements with respect to orientation using a single axis gyro versus a multi-axis gyro, which is going to have the benefit of getting the east-west readings and then averaging that out and it's when it presents the data to you.
Okay, I guess I see what you're saying. Let's see.
Not sure what happened to Franco. I sent him an invite. Oh, there he is. He's back again.
Yeah.
Let me see.
Yeah, he had some questions. Did you post that video that you're talking about, the interferometer?
Nope, I'll send it to you now, though.
Yeah. Let's see. Yeah, okay, maybe. So, these are different things. So, like the caging of a directional gyro would be used for heading north. And then you have an initial gyro compassing to calculate your initial heading.
Yo, what's up, Franco? Shout out to Big Franco.
Hi.
Mord One was saying that you had some questions, comments, and concerns.
I had a comment. I didn't on the Sagnac effect because I'm not really into all the details. But my comment was that when I was hearing what was being discussed, the assumption was always that the rotating frame would be comparable to the stationary frame, and with just by using special relativity, meaning that they're both being considered as inertial. But this is not the case because a rotating frame is not inertial with respect to another. If one frame is inertial, then a rotating frame with respect to this first system frame is not inertial. They cannot be both inertial if they're rotating one with respect to another. So now, what the explanation for the Sagnac effect is, I just found papers that say that it's perfectly explainable with just special relativity, but just by integrating proper time over the correct word line of the object. But I've not. I have to read that before I can discuss it. But I didn't want to discuss that. I just wanted to make that comment that what I was hearing, in my opinion, is not correct because a rotating frame is not inertial. Then my other comment was about muons because I'm more expert on that because I don't understand what was being said about special relativity not being applied correctly to describe what happens with muons, and that I'm not. Of course, I'm not. I don't agree with.
All right. Well, let's see. Let's start with special relativity being valid in a rotating frame. Since you're big on particles and all that, I'm sure you're familiar with Thomas precession, which is how they use length contraction and time dilation to explain the anomalous orbit of an electron. They say basically what you can do for Thomas precession is you can define any infinitesimal points between the orbit. So essentially, you just pick a point here, and then a couple seconds or whatever time interval later, that electron will be in a different spot. So you'll take that point there. But of course, because it's traveling around a circuit, an ellipse or whatever, it's going to be curved a little bit. So what you can do is you can get the hyperbolic cosine angle of that, of the difference between that first frame and the second frame, and you can reorientate them to make them linear and orthogonal to one another, and then you can do your Lorentz transformation, which they call that doing a Lorentz rotation, and then that's equivalent to a Lorentz boost when you do that. So they make it valid for the analysis of the electron to apply that in a rotating frame. So it's been canonized that it applies in a rotating frame, for one. And then number two, what were your thoughts on what Einstein said in his 1905 paper, where he specifically defined a uniformly rotating frame as an inertial frame, and his equations will apply, which would, be applicable to an interferometer where you have a source that's going to be one observer, and you have the recorder that's going to be the other observer, and then you have the rotation, which is the relative motion between them, but they're both inertial observers as defined by Einstein. So they should predict that the speed of light will be constant. So irrespective of the rotation and the distance changed between them caused by that rotation, there will be no fringe shift pattern unless you assign imaginary vectors to points in space where electromagnetic processes occur, which is what happens when you get into the explanations for the Sagnac effect, when you say that, it's been proposed that, like this paper says that, with the correct world line, it has an explanation, but that world line with respect to what? That is the absolute reference frame that has to be invoked for the first order timing difference to be accounted for in the distance change of the rotating apparatus. Without that, you don't have any explanatory power at all, because as you pointed out to me once, the link contraction and time dilation are functions of velocity squared over c squared, and those are much, much smaller effects rather than the directly proportional effect of the rotation, or in Wang's case, linear motion being measured.
I didn't follow, and I need to read equations and whatnot. But what I insist on is that it cannot be stated that the rotating frame is inertial. But if a rotating frame is rotating, of course, if you have two frames rotating one with respect to another, then if one of the two is inertial, the other one is not. They cannot be both inertial. That's the definition. You have tangential frames. You have local. When you have a rotating frame, you have local, so-called tangential frames, which are frames which locally have the same velocity at some point, and in the neighborhood of some point of the rotating frame. But you cannot consider the rotating frame to be inertial. That's for sure.
Well, I would certainly agree that a uniformly rotating frame isn't an inertial frame, especially as defined by the model that I subscribe to. But in the case of relativity theory, in regards to where the laws of mechanics apply, Einstein specifically stated that they would be valid in a uniformly rotating speed in any closed polygonal loop or any continuously curved line, which is also just known as a circle. So I understand where you're coming from with your analysis on it not being a valid inertial frame, and that's typically the response that's given. But it has been mathematically canonized that the equations do apply there, and that they should. So if Thomas precession falls under the dominion of special relativity, I don't know how you could say that it doesn't fall under the dominion of interferometry.
I didn't really get the connection between this and Thomas precession. I'm just looking at an equation giving exactly what happens, what is supposed to happen, and what happens. I don't know if I can post it, but the equation of what happens to the spin of an electron the relativistic equation for the behavior of a spin of an electron in a magnetic field. That's what I'm actually currently preparing a lecture for tomorrow, and trying to explain to students how the beam energy at LEP was measured at the LEP accelerator, and it was using the so-called resonant depolarization of electron beams in the magnetic field, and that was actually using how the spin of the electron is behaving at relativistic speeds in a given magnetic field, and that was used and that was measured and that was perfectly compatible with relativity. And I'm assuring you, as I always try to do, that everything that we use in high energy physics is perfectly compatible with special relativity. There's nothing that we use every day and with every kind of measurement and even practical things such as actually building the detectors, actually building the accelerator and magnets and vacuum tubes and accelerator tubes and whatever. They all need to comply with physics law, which take into account special relativity, and without that, nothing would be working. Nothing would be consistent. We actually using the relativistic form of the equation for the behavior of a spin in a magnetic field. I can post the papers for you if you want.
Yeah, so I'm not talking about the magnetic moment specifically, right? We're talking about Thomas precession. I sent you a DM on rapidity, which is how they use that deviation angle between the two frames for the motion of the electron in its orbit around a nucleus, and in regards to how they, make relativity apply to a rotating frame, because the electron, is in an orbit, it's in a rotating frame.
So there's no nucleus. We're talking about electron beams in a ring, storage ring, and which are polarized. They get a polarization because of physics. Because even with relativistic physics, what happens with beams circulating in a ring, and they get polarized, and then with other magnetic fields applied, they get depolarized, and that depolarization gives you information on the energy of the beam. That is one of the things that used with very precise measurements at high energy colliders, and that there's nothing moving in nuclei. It's electron beams.
Yeah, I think we're talking about slightly different things, because the analysis of it is based off of the electron orbiting a nucleus and how it has a slight deviation in its orbit, and they attribute that through link contraction and time dilation, and they make the equations apply for special relativity in the rotating frame by establishing what they call the rapidity, which is the angle that's the deviation between those two frames, because the world line and the x-axis, are always perpendicular to one another. But if you take a rotating frame where you're going to be, moving on a curve, right, you're in a slightly different spot. So you're not going to be exactly 90 degrees like the other frame that you started with. You're going to deviate a little bit on your x and time axis. So that rapidity angle brings them back into frame. So what I was saying was, following that sort of analysis and making relativity apply in a rotating frame the way that they do for Thomas precession, you could equally apply that to the Sagnac apparatus with the light source and the photographic recorder as the observers.
I'm not sure I'm following, but okay, I know what rapidity is, and I know how it's used in high energy physics. I know, I know what it means when it's related. Well, yeah, when it's related to Lorentz transformations. I don't know. My objection was that you claim that special relativity is not correctly applied in high energy physics, and I assure you that this is not the case. And also that we have confirmations of it with every measurement, and especially with the very fact that the accelerators work. As I was once trying to ask you, if you want to determine, for instance, what the magnetic field, what magnetic field you need in order to bend electrons along a circular path of 27 kilometers circumference, you have to make a calculation of how large a magnetic field you need, and also what the velocity is for these electrons going at having some specific energy, for instance, 6.88 TeV currently running actually the protons in the LHC, or I don't know, 45.6 GeV electrons in the lab. You need to know you have this energy for the beams. You need to know what magnetic field to have in order to bend them along this circular path. You need to know what radio frequency to have in order to accelerate them along that path, and these things. And these things are all completely determined by special relativity. And this is just one of the things just to make things work. But then you have detectors which see what happens with particles coming out of collisions and how they behave in magnetic fields, how they behave when you treat the momenta and measure momenta and energy and combine them to analyze them. And it's all done using special relativity, momentum conservation, for momentum conservation, and things like that. There's nothing, even if you look at lifetimes, the lifetime of unstable particles, and the measured decay lengths of decaying particles, they're all obeying the time dilation prediction. And if you look at, for instance, peak walk meson measured lifetime and measured decay length, it depends on the energy of the meson, exactly as is predicted by special relativity. So we have confirmation every day. It's not an issue. Absolutely not.
Okay, well, let's start from the beginning a little bit and see if we can agree or disagree on the relativistic lens that's being applied to the experimental interpretations here. So you're asserting that time dilation is a relativistic effect is the correct interpretation of experiments, especially regarding muons in the lab. Now, would you agree that Lorentz symmetry is the change in distance and time such that it allows for symmetrical transformations between inertial frames? As defined by relativity regarding the inertiality, the inertiality, if that's a word, of the frame, if you know what I mean.
No, I'm not sure what you mean by symmetry. Well, I know what Lorentz symmetry is, meaning that you have physics that is invariant when applying Lorentz transformations.
Right. What makes a successful Lorentz transformation to satisfy the space-time symmetry, right? It's the symmetrical use of link contraction and time dilation. Would you agree?
I don't know what you mean by that. I know what I know that what Lorentz transformations are and how they are derived and what their implication is. I'm not sure what you mean by symmetry and the fact that you have to apply. So you have to apply Lorentz transformations as they are.
Yeah. Right.
You have to transform both the space coordinate and time coordinates. That's true.
Yeah, 100% agree. So to satisfy a Lorentz transformation, you have to change the time coordinate and the distance coordinate. 100% agree.
Yeah.
So when we get into the muon analysis, right, first of all, there's no reciprocity in time dilation in the lab frame, and there's no link contraction in the time frame. So like the perspective, like the reference frame of the muon, because it's traveling at the speed of light, from its reference frame, it appears stationary and the lab frame is moving towards it and experiences contraction. None of that is established in the analysis of the muon, which, violates Lorentz symmetry. So it's an invalid use of the mathematics to interpret that experiment through that lens.
No, I don't understand what you're saying, and I don't agree. It depends what muon experiment you're referring to. If you're referring to cosmic, any. Okay, I posted. I keep on posting this. a plot from the G-2 facility showing the decay, the exponential decay of the number of muon counts, right, as a function of time. It's a beautiful exponential. The envelope of is actually an oscillation modulated, say, enveloped by an exponential, and the exponential is beautiful. It's in logarithmic scale, so it's a straight line in a logarithmic scale. You can measure it even with just a ruler, but just from the plot, the decay constant of that exponential, and that would be exactly the lifetime of muon decays in the lab frame, and you measure that, and it's not the same as you get when you have muons at rest. The decay time constant of meaning what is called a lifetime, which means that is the exponential scale of what that you measure when you have muons at rest. It's 2.2 microseconds. That's the lifetime of the muon. It's been measured, and it's on any database of particle physics. Then you have that when you have muons which are not at rest and have an energy that's measured in many ways, for instance, by knowing what magnetic field you use in order to bend them in the storage ring, you measure their decay length, and their decay length is exactly perfectly measurable. It's measured with extreme precision. You can see that from our plot, and that agrees exactly with what is predicted by relativity, because it's dilated by the gamma factor, and the gamma factor is the ratio between the energy and the mass of the muon. So this is a beautiful confirmation of relativity, but we see it not just with muons, we see it with any kind of particle which is unstable and of which we know the lifetime, which is measured at rest. You can measure it at rest, or you can measure it as a function of the energy of the particle, and you see that the measured lifetime as a function of the energy of the particle follows perfectly the E over m dilation, which is predicted by relativity. So we don't have any thing that contradicts what is expected.
Well, I would start by saying that the contradiction exists in the mathematical interpretation of not satisfying Lorentz symmetry by adding contraction and showing reciprocity in the frames where the other frame shows the link contraction and the time dilation and the muon doesn't. When you get into the rest frame muon, right, that's a calculative value. No one's measured a rest frame muon. These are all things that are
Why did you say no one has measured rest frame muon? You have muons at rest. You shoot muons into a target.
Is a muon that gets shot into a target at rest? But anyway, I don't dispute the accuracy of the measurements or their existence or anything like that. What's in contention is the physical meaningness of the equations that are used for the interpretation. So when you have a theory that is dependent on satisfying covariance, meaning satisfying changing the length component and the time component, if there's a discrepancy in those two, then you don't have a valid you're not using the math in a valid way to provide a physically meaningful answer. Like you're just doing pure kinematics. You're choosing an asymmetrical use of covariance, and then you're not you're never rectifying that in the analysis. So we lost Franco. Let's see. All right, well, hopefully he comes back, but that's my answer to that. And let's see. It's getting super late though. So if he doesn't come, if he does,
this like 2.5 hours, right?
if he doesn't come back in like 2 minutes, like I'm willing to wrap it up. Mord, I want to thank you for an excellent conversation, man. Much appreciated. Sorry I got a little heated at the midpoint there, but it was great. It was great discussing it with you, man.
Yeah, I'm curious just to look into more about the one thing that I've never talked to you about is the Ely effect, which is maybe the best substantiation of some sort of sidereal effect on pendulums. But maybe we could talk about that another time.
Yeah, for sure. There's actually 4 effects that have different periodicities to them, apparently. I'm not super up to date on them, but I can link you Toby's stuff. He went in depth on them, did a couple prezzies on them.
Cool. And yeah, it was a good conversation. I don't know if Austin's still there, but that was a good conversation also about geocentrism and stuff. So
Yeah, that was fantastic, you guys. It's so much information. I'm going to have to go back and re-listen to some of those segments that you were talking about, and I'm sure a lot of other people will as well. But good exchange.
included.
Nice recovery too when it got a little tense.
Yeah, no, it's good. I mean, I try to keep, it's always best to like reset and keep things civil, I think. So I'm definitely going to go back and review a lot of this stuff. So yeah. And I did start reading the relational mechanics book as well. And apparently has a talk on YouTube. I'll link that as well because it's kind of interesting, but yeah.
Cool. All right. Well, I'm going to head off of here, lads and ladettes. I don't know if Witsit's there or not, but everyone have a good night. Thanks for hanging in there. I'm sure that was a really long and dry conversation, but it was a lot of fun.
Alan, if you're the only other one that has controls, I don't know if Witsit went to bed or whatever, you might have to end the stream, I'm thinking, or no?
Oh, I can't. It's solely up to the host.
Okay.
Yep.
Everyone's just gonna awkwardly hang out here in silence for hours until Austin wakes up the next day.
Yep. Good luck. Happens to me every Friday on Flat Earth Fridays when I'm asleep and they end.
Yeah.
It's just like 2 hours of nothing.
Yeah.
Speaking of Flat Earth Fridays, see you guys tomorrow for Flat Earth Fridays.
Oh, Jesus, man. It's already Thursday.
Yeah, you want to bring up anybody like Proud or Sacred to say anything about Flat Earth Fridays, or I don't know if they're here and they want to say anything, or
I'll give it a shot. But if not, I'm heading to bed.
But congrats to them on 10K for their subscription account on Twitter, X. Awesome. See. All right, Flat Earth Fridays, everybody. See you there.
All right, cool. See you guys tomorrow. And then I think Witsit's going to do, today's Thursday, right? I think there's going to be a Schooling the Globers today. So stay tuned for that. And then what were you going to say, Mord?
Oh, nothing. Just, yeah, good combos all. And I'm curious to maybe discuss more on the aspect of the mechanical gyroscopes because I guess that's the biggest thing for me with regards to like a claim of, I don't personally see how they would communicate with the move, like how the aether wind would communicate with the moving physical gyroscope. Like if the ether wind is a medium of transmission of light, then in some sense it makes sense. And I think it was hypothesized by Sagnac, right, that the ether would, and given the history of Michelson-Morley and stuff and the other interferometry experiments, that I think it makes some sense to me that it would affect optical gyroscopes, but I just don't see the mechanism that it would affect the mechanical ones. But maybe we could chat about the Ely effect and stuff and see if we could make it make sense.
Cool.
Do you mean the Elias effect?
Yeah, I always pronounce French things horribly wrong.
I think his name is Alay though, or Alay.
Yeah,
Or no, it's
the
Alay.
guy
I
was
think
an
I can't
economist,
remember.
and then he got bored of economics and decided to do physics. I mean, what a
He was,
chat.
he was both. He was a
Yeah.
physicist and an award-winning economist or economist or whatever. But there was one other thing. Oh yeah, so Tuesday, tune in to Ether Cosmology and my channel as well. We'll be doing a presentation on relativity of simultaneity. Bennett just wrote a new paper, so we're going to be doing a world debut of that regarding the old thought experiment of the classic train in motion relative to two simultaneous lightning strikes with respect to some other stationary observer. So that if that doesn't sound like a lot of fun, then you probably won't be there.
Yeah.
Buy
The
some
real question
brush
is-
tail coffee.
The real question is if I will be there, since I got on that train in the first debate, and maybe I'm dead. I don't know.
Yeah. So you would be super dead, but shout out to Omnivore, who is the only one who was like, "I'll get on that train." Like he gets it.
That's
He's
funny.
the only one, and I mean it in the most respectfully way possible. He was like, "Yeah, put me on that train. It's gonna be different." All right, later, lads. See you guys
Have a good night.
tomorrow.
Good night.